Right, the stream is now. Now is the stream. What's going on, everybody? Can you hear me? What's going on? Sounds like you can hear me. How is it going? Let us make our official announcement. Welcome to the stream, everybody. Do a little red circle. And you guessed it, Frank Stallone. Nope. Compiler work part 32. Hey, and my phone's not on silent. What a great reminder. Ooh, and someone just texted in general. And then Twitch with the sabotage. Mobile live dashboard that I never use. Alrighty, we're live. They're talking about Rust. They're talking about Rust in the Discord. So let's get rusty. Yeah, let's just get going. Let's navigate our way to the compiler. And oh yeah, so the if we take a look at the pointers example. Eternal Wild Fox, hello, how's that going? What is up? If we take a look at the pointers example, we can see that it is terrible. And it crashes halfway through on Windows. And I tested it on Linux last night, and it just gives a bunch of errors about not being able to find these variables. Eternal Wild Fox says, I got my CMake up and ready with a manifest file. How are you doing? I'm doing good. I'm not sure what that means. What's a manifest file? Is that like a JSON file with all your dependencies and stuff? But thank you for asking, Eternal Wild Fox. I appreciate it. Eternal Wild Fox says, yeah. I see. Not yes, John. Fun fact, a crocodile can't stick its tongue out. Also, you look amazing, though I can't see you. Wow, thank you, John. You're always so kind. Thank you so much. I bumped my microphone, so I'm just going to spin it back towards me. Eternal Wild Fox says, I wrote it down, how it works. Is it in the Discord? I'm sure it's in the Discord. VC package. I see. So this would only work with Windows, right? Is VC package cross-platform? I don't know what VC package is. I've never used it. It sounds like a Windows only thing, like a Visual C. Could be cross-platform. I just don't know what VC package is. Am I just out of the loop? Should I know? Nice, used a submodule to use to get GLFW. That way you can just add subdirectory. Pretty pog. VC package also runs on Linux, I believe. Nice. I don't know what it is. I've never used it. But this is also just what I use. So I think it's just a different way of installing these. You know what I mean? It's very cool, though. I like it. I like learning new stuff. Makes me puke. That's amazing. I mean, it is a systems language, so it's expected, but damn. I don't know why everybody's surprised Rust is in the Linux kernel. I kind of saw it coming. It's like, oh, you mean the syntactically horrible Linux kernel? You mean they're gonna like Rust? Weird. Streamer mode is enabled. Stay safe, friend. Lamau, thank you, LanderXT. So awesome. Thank you everybody for tuning in. We should get to work on this compiler. I don't know what we're gonna do, but we should do it. So yeah, did we ever run this pointer example? I think we did, and it just, yeah. This isn't a good sign. You know? So let's figure out, let's just look at let's load the editor. Which I still have refused to Add to my auto load. What are we looking at? Pointers. Okay. So you can see that we have putter here, which is a pointer to an integer. And it's not happy about that. Eternal Wild Fox says, VC package works on Windows, Linux, and Mac. Nice. That's crazy. So you get the main three. That's pretty good. It does add another dependency if you wanted to port it to another OS, but I don't think you're worried about that. Putter, test putter, B, A. Looks like A, B, putter, which is a pointer to an integer. Test putter, pointer to an integer. Putter, pointer to an integer. Lender XT says, what about Linzer OS? I only use software supported on Linzer OS. I mean, that's the idea. You want the least amount of dependencies possible, so it's the easiest to port. That way you only have to port like Git, and then you have to port like GCC, and then you have to port like what else would you need? I think bare bones, that's all you'd need. Ideally we'll port like make or CMake eventually. I mean, technically we've already ported make with GNU bin utils, but we just have to support the proper syscalls at this point. Okay, so we have an integer as a type. We have variables on the global level, foo, bar, number, numputter. Hey, Sirade says, yup, what are you up to today? I don't know, I'm working on the compiler. Eternal Wild Fox says, maybe I also look into CMake's fetch content, which can directly download GitHub files. Oh god, no. Check this, CMake latest module fetch content. Yeah, try and make it as simple as possible. You don't want it to just do everything automatically. Use a shell script with like curl if you want to download stuff automatically. That's at least, I feel like, a little more understandable as to what's happening, both to the user and automation-wise. That way CMake can just build your build system. But I agree, with Lenser OS, it's CMake got abused. Sir Aid says, I usually just bundle all dependencies as submodules. Nice. You like pulling your hair out too? Me too, man. Me too. I love submodules. Yeah, they work great for now. No, I'm kidding. They're pretty good now. Submodules are pretty good. So we got to figure out why this is crashing. Just says no. And I hate to say it, but we're going to go there. It's going to be a Visual Studio time, because they're jumping straight to the exception is honestly pretty handy. But I already know where the problem is. I'm fairly certain. It's in source / I would guess it's in the parser. And it has to do with not setting up the proper pointers in the context, is what I would guess. We'll see though. We'll see where we're at. Okay. Yeah, we don't need that. Any others? Nope. Okay. Are we compiling pointers? I hate how hard this is. Pointers. Thank you. Different example. Sir Aid says, I think pretty much every single one of my C++ projects has lib format as a submodule, lol. I don't even know what lib format is. Am I missing out? I feel very out of the loop today. Is it happening? Okay, it ran and it stopped. That's not ideal, I guess. So, that means we're here. We're thinking about what is going wrong. Let's try and think about where we get to. Okay, let's try and build and run it. Oh, that'd be funny if we're just running an old version of the compiler. Yeah, we'd like to build, debug. I guess we can use build now because of our Sir Aid doing that lovely work on his GitHub pull requests. We now have release mode assert. LanderXT says, who uses C++? I only program in TI-84 assembly. Game calculators. Eternal Wild Fox says, I'm going to research CMake further. I want to get the GitHub submodule working with all. Nice. Sir Ed says, lib format is basically a better alternative to printf and IO streams, so that last part isn't much of an accomplishment, let's be honest. I think IO streams are great. Not that bad. I think they're a little better than the file API of C. I mean, C is simple, but it's also very simple. Like, it just sucks to write anything that isn't a struct to a file. That's the examples and pointers. Oh, I'm in the wrong spot for that. Okay, perfect. Hey, look, we were just running an old version of the compiler. But there's still many errors. I'm going to presume that code.s did not... Yeah. Uh-oh. I know something that should not be here. Can you guess what it is? Oh, Christ. Could not find A in locals environment. Okay. So this is CODEGEN, obviously, because we outputted code. Sir Aid says IO streams are horrible. Why? I've refactored a lot of code using IO streams to use libformat instead, and it's much better and simpler and a lot faster. I mean, it sucks to like format a hexadecimal number, but it's not that bad. LanderXT just said the Pope. I don't know what that was in reference to or if I missed it, but I like just the Pope as a chat message. What am I looking at? This is what I'm looking at. So we're looking at a variable access. And it says symbol to address. Okay, so... See, we don't call symbol to address in the variable access, do we? We should. Where did it go? I feel like I skipped to it and then it disappeared. So we find where the variable lives, what context it lives in, and then we say if it's a global variable. Is that how that works? I don't know if that's correct. Okay, I think I may know what's going on. Okay. LanderXT says, that's the point. There was no point. I just said the Pope. Then that's perfect. That's exactly what I was hoping for. I like it. So basically, when we're trying to do a variable access, it seems like we got our math wrong a little bit here. Because if we were dereferencing here and then breaking, that means the only way we'll ever get here is if it's if it got. Right? So are the global variables? I'm pretty sure the global variables are added to whatever we're talking about here. What are we talking about? The CodeGen context. Are they not? They may not be, because they don't need to be. They're not locals. Okay. But these aren't global variables is another thing. We should be in a scope. Okay. Oh, Christ. It's going to be a little bit. So, effectively, the only way we could get here... Okay, what code are we generating? So, move racks null. That's a reassignment of A to 0. No? Yeah. So we declare A. We do a reassignment. And then an integer. I noticed there's no stack space allocated for A, which is kind of interesting. So variable declaration, right? I know we're looking at the reassignment. I just want to make sure. And effectively, temp node value symbol is an external function and break. Because we already have the memory address. Okay. Okay. Sorry, I'm just rereading my own code here and trying to figure out what is going on. You know, the classic. So we basically get the size in bytes from the types environment. Subtract it from the stack pointer, keep track of the offset, blah, blah, blah. So A is a pointer. Should definitely not have this happen. Okay. We're getting error symbol to address could not find. So we're probably in the reassignment. And set result to operand representing left-hand side that will be written into. Okay. So, yeah. We're talking about left-hand side of the assignment here. So we're saying, figure out what this is in the code gen, like what this actually is. And effectively, if it's a variable access, we look in the current context on the expression children, which if we look at a variable access, what is that? Don't they not have children? Oh, but that's expression children type. So this just sends the variable access itself. Lender XT says Serene Doge. Yes. Okay, so it is a variable access of putter. So CODEGEN context isn't correct. And also, how is symbol to address returning an error? It's not. See, it's a specific thing right here. In symbol to address, we say if not, no, if not CODEGEN context parent. Okay, so what is CODEGEN context? It's not null. We are getting a symbol. Should probably check type here. In any case, we are getting a symbol. We are getting a context. It's just the wrong one. So just give me an idea here. What do we got? Okay, it's always global. You can see it's never changing, which is not ideal. Oh no, it is changing. See, so we are getting a different CODEGEN context. So let's print out, what is it? Parse context print or something? No, this is CODEGEN context. I don't know if we can print out a CODEGEN context. I don't think we ever wrote that. We did not. What's in it? We have the locals environment, the register pool, and the locals offset. Let's print out the locals environment and figure out what's going on from there. What do we got? I don't remember what it's called. Okay. So we never printed anything out, which is pretty funny. So what is CODEGEN context locals? I wonder if I should just go to Visual Studio and put a breakpoint here, symbol to address. Address. Okay, it's not in here. Oh, we're in the wrong place. I'm gonna steal you. Thank you. Thank you. Okay. Neg Borsa says, hi everyone. What's up, Neg Borsa? Lander XT says, should I carry on with these random chats? Sultan, the Sultan of the Sultan Sultante. I like it. Only if you want to, Lander. It's up to you. They're entertaining. What's the issue? So basically, let's just get here. We're going to fall to the beginning of this statement. What is our CODEGEN context? Parent is global because its parent is null. It has no locals. It has 17 registers and 7 scratch. Just like we do, I presume. 17 registers, 7 scratch. No locals. So we're doing a variable access, and our variable declaration hasn't created a local thing, which is confusing because we set it right here. So let's just print setting local here, right? And then we're going to print the node of expression children. Okay, see, we're getting somewhere. We're getting somewhere. Oh man. Wait, is that? Does not equal 0. String compare returns 0 when they're equal. I'm trying to skip external functions here because we don't want to CODEGEN them like at all. But we do want to make, I mean, I guess we don't even have to check if they exist. Right? I guess we need temp node to see what the type of the variable is during the declaration. But yeah, that should be equal 0. I think that's screwing us over. Hey, look, I'm pretty sure that was it. Lamau, string compare, getting us again, returning 0 for success, like a truthful Java programmer would. Lamau. Awesome. Let's just make sure that the code that it generated no longer is null in it. Hey, look, no more nulls. If we take a look, everything looks proper. Yeah, variable declaration A. See here, the sub is back. We are back in action. I know what we should do is probably just keep track. Ooh, that's probably a good to-do to write. To-do. Add to the giant list. What was I just talking about? I totally forgot. I just goldfished entirely. Hopefully someone remembers. All hail the JVM. That's right. Return 0 for success, like a true champion. Like, oh, you mean comparison? I really just totally goldfished whatever I was thinking about to write in that to-do. I got nothing. gonna drink some Gatorade. Because why not? It's 9 in the morning and I want to feel like an athlete, okay? Not a mathlete. But I feel like a mathlete because I can't open the Gatorade. I got it. Oh, I got it a little bit, but now my hand's slipping again. Yeah. That was harder than it should have been. Oh, I'm having a great morning. Ooh, it's like Kool-Aid. Oh yeah, this gets me excited. I'm an athlete, everybody. You want to see me run? You want to see me do it again? Oh, this is so horrible. We should really not do the string compare. We should probably have like the attributes thing I talked about. Oh, I just remembered, everybody. I no longer goldfished. Hey. Basically, also, sorry for not making the code big. I totally forgot I'm streaming. Subtract stack, local stack allocation at beginning of function. I know this is going to require like some backtracking or whatever, but it's okay. Subtract, or just like some look ahead where we go through the entire function body, look through all the variable declarations, and then figure them out. So this is like an optimization. I'm just going to start doing that. Perfect. That way, in the runtime, we could just subtract once from the stack all of these different cases. So instead of subtract 32 to give us some space for external calls and stuff, clobbering the stack, then what we do is we'd subtract 40, and then, oh, it's actually 48. Oh, it's actually... Does that make sense? 56. And then we could just subtract all at the beginning, do one instruction, and save all these subs throughout the function. It's an optimization we'll have to make. And, yeah. To do. Optimize to subtract all local variable stack. Size, I don't know how to say that. All local variable stack size at beginning of function rather than throughout. Sir says, I'm back. Do we know what's wrong yet? Oh yeah, we fixed it, buddy. This was a not equals instead of an equals. This comparison, it was a not equals instead of an equals, and that killed us. But yeah, we hunted it down. Everything's working again. We can go to code.s. We can compile. We'll just use GCC, and we can run it. And failed with code 69, as we should. How beautiful is that? I also updated my Emacs config and broke everything, and then tried to fix everything. So yeah, I hate org babble sometimes, but it's nice. Sir Aid says, ah yes, a string compare bug, that's a classic. It really is, it really is. It just shows me that we really shouldn't do this. I think external should be an attribute of a node, and we need like an attributes API. But I don't know if I'm gonna work on that right now. Well, maybe I should. This is fixed. Fixed. Hey look, it only took me like 30 minutes from finding the bug to fixing it. That's pretty good. We'll give it a little commit the push it. Sure, save that. Okay, what do we got? Also just get rid of those. What do we got? Oh yeah, I forgot. I did stuff yesterday. I was like, wait, what? But I remember now. Also, what did I change here? Oh, I just added a space so that they line up. So yesterday, I went through and added some things to registers. But I didn't do anything interesting. Here's our change. This whole section of code is pretty non-radical, dudes. Maybe we should work on that as well. We can implement that. We can stage that at the same time. I'm just curious where this is. Variable reassignment. Yeah. Oh yeah, it's very non-radical. Oh no. Why would we not just return an error? What is wrong with me? Sometimes I don't know why I write the code I do. In any case, it opened another one. I thought it was going to take over that one. In any case, we have fixed this little bug in CodeGen. So we're going to fix this little bug in CodeGen. CodeGen. Fix backwards comparison of stir compare result. Is it stircomp? Do you say string compare? How do you say it? Chat, what do you do? Sorry, it says, by the way, any idea as to when you're going to work on the test framework would be nice to have in case stuff breaks again. And of course, I kind of really want to see you come to terms with the idiosyncrasies of algol. Lamal. Yeah, I'm working on it. Basically, I was gonna do it yesterday, but then there's stuff happened in my life, and medically, and I can't go to a doctor just because I'm in America, and they're not they're not so much doctors as they are snake oil salesmen. They get paid to do like speaking engagements by pharmaceutical companies. It's pretty sketch. It's pretty weird. So, you know, yesterday I just took a chill day. I'm like, well, I'll be my own doctor. And I prescribed myself 1 day of rest. And then I didn't do it. And I didn't stream or do anything yesterday. I just played video games so that nothing happened again. And then I woke up today and I was like, I gotta stream. But I have no direction today. I'm just like, I don't have the motivation to like learn something new. I'm tired. I'm just gonna, you know, fix bugs, do nothings. Kind of want to change all the code gen into a different thing like this. This would be nice. So change it into where we have like top level code gen, and then all the platforms get included through this header, and then all the different platforms are in directories. Sorry, it says fair enough. Lander XT says, God save the king, cup of tea, free healthcare, UK best country. Can I move there for like 6 months, get some free healthcare, and then come back? So I do like parts of America. Just not the people in it. Yeah. Things are working now. Let's separate CodeGen. Let's do some organization, huh? So let's think about where our register stuff is going to have to go. So basically, I think we're just going to make init register not undefined. I know that's not best practice, but I think that's where we're at. We're just going to define it in CodeGen .h and not worry about it. Lander XT says which parts? You know, like the parts that are above water. But in order to have like all the x86 stuff in one directory, we're definitely going to need x86 registers. Lander XT says can't argue. Okay, so if we had, what if we just had all our registers in one file? The register pool register structs are supposed to be architecture agnostic. Yeah, I was going to make registers, this is very architecture agnostic. I'm not saying put register stuff in x86-64. I'm saying this register stuff. because all this is x86-64 for a singular gas. You know what I mean? So if we did like CODEGEN / x86-64, we could have like registers.h, right? So if we had x86-64 registers.h, then we could, like in gas, use the registers, and we could in NASM use the registers. But we're going to need different register name functions for each one of these, you know, because this percentage sign is going to be a little issue. So it seems like it's going to, like, there's going to be a lot of architecture-specific functions that need to exist, you know what I mean? But they also need to depend on all the register stuff. So it's going to have to go in some header. So is this doesn't return anything here, it just panics, which is a no return, so that's fine. Sir Aid says, I suppose the easiest thing to do would be just yeet the percentage and add it in the gas backend specifically. That'd be really hard, but yeah, we could do that. Basically, anywhere we call register name, we just have to add a percentage. I don't know. I feel like there's not really a problem with, we're already going to have like different ones for Microsoft and Linux because of the ordering of scratch registers. So I don't think it really matters that all this is going to have to be architecture specific. I don't think it matters. We're just going to need to put it all in registers. So we're going to need like registers.h, right? Which is going to have all the register stuff. And then each CODEGEN, like each format is going to have to deal with its own. Let's see. Not CODEGEN context, but its own register pool, which is in the CODEGEN context. LenderXT says, Creeper is my favorite CPU architecture, Lamau. But yeah, like this would be all of x86-64. So it's almost like we should have like a CODEGEN / x86-64.h and C, of course. And these contain like all the like broad architecture details. Like we could have, I don't know. We'll have to think about it. I don't know if that really saves any work, you know what I mean? It's just doing object-oriented stuff, basically, for no reason. I think we can just do designed by Gun McGunface in 1969. Lamau. Oh yeah, by the way, what I added is I added a way to get from a register descriptor to its single byte register name for every register. And it's a word register name, and it's double word. So for 64-bit, this allows us to access 32-bit, 16-bit, and 8-bit values. And I figured that'd be pretty good. I don't know where we're going to need to use it, but I'm sure we're about to need it a lot, because we're going to implement a byte type soon. I feel so dumb right now. I'm just jumping around the code, not doing anything. I just have to think about how this is structured. Lots of CODEGEN expression. And then CODEGEN function, which is pretty simple. And CODEGEN program. So effectively, I would love to have all of this in one place. Not that. That's probably going to be like here. I don't know. Let's put that in CODEGEN.h as an extern. And then we'll just have alrighty. So basically this will just say, if it's verbose, set this to non-zero value. I think comparison type can stay at the very top level of CodeGen, but it means we're going to need this move to CodeGen.h, along with a lot of the register stuff. We'll see. We will see. So register name, allocate, blah, blah, blah. These are all going to have to go into its own thing. I think label generate is going to be just specific to the architecture. So I think we can actually do something like this. Because this is label generate for x86-64 MSWin, I'm pretty sure. Or at least it's for gas assembly syntax. Like this won't work across platforms. So should probably rename that and stuff. Or just have it be static. And go in the x86-64. Is that all fine? Or not fine? Follows non-static declaration. Okay. Is that in CodeGen.h? Label generate? It is. I don't think it needs to be. Sarade says, oh, that's nice. I think that was earlier. I'm probably just rereading it. Okay. Everything is still working, and I think effectively we're going to need, so this register descriptor is valid. This is definitely architecture independent. This can be used for any architecture. 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 More or less, this can be used for any architecture. Sraid says, I suppose since external calls are a thing now, it would be nice to have x86-64 Linux backend so that I can actually run the code on my machine, lol. And if you're refactoring CodeGen, then adding a new backend might be a good test. Maybe I'll look into that later. Absolutely. Yeah. So let's just do all the register stuff. I think we're just going to take this into registers.c. We could keep it in, we could just also do this type of thing. See, but we need a CodeGen context for that. So CodeGen context needs register pool. So this just has to be declared below this stuff. Automod holding Lander XT back. He's like, are you sure you want to see? Oh, Lamau. Lander XT says, thanks Twitch Automod. I let you through, don't worry. Lander XT says, just make one backend and tell anyone who prefers anything else to fuck off. Lamau. It's true. No, we're going to support Linux, Windows. We're going to support a lot of things. But yeah, you're right. We should definitely add CodeGen format for Linux. So all this register stuff is completely cross-platform. So we need the register pool for CodeGen context. We need the CodeGen context for all these. That's fair. And effectively they can be implemented here. That's fine. This stuff is going to have to join x86-64 registers. So in the gas backend, which is what we're currently writing, if we instead just returned no percentage sign, what would that look like? Right, so we say percentage %s, which is symbol value symbol, LLD RDP. We already do quite a bit of the How would we do this? It'd be like that, right? Okay, I think, Sir Aid, you might be right. Where it's easiest to just yeet the percentage sign. You may be correct. That way we don't have to rewrite all of these for gas, nasm, phasm, etc. Sir Aid says yeah. It's gonna break things. It's gonna break things, but I'm in a destructive mood today. Screw it. So this is architecture dependent. Values honored between 0 and maximum must be a valid register descriptor. Yep. This is architecture dependent, but this is like broad. Well, this is not quite broad. So here's the thing. So register name, if we just get x86-64 registers, that means we're gonna need a register thing. Oh boy. You ready for this? Okay. Hear me out. I think we're gonna end up with all of x86-64 registers. As its own enum. Right? So we can do this. Sir Aid says, oh dear. And then these can equal. Do you see what I'm saying? Is that gonna work? Why are you mad? Oh, it's a capital. Right? And then when we get this register, it'll be equal to this descriptor, and we can use the register name that we set up here. Am I making any sense why this is needed? Because now we don't need, like, our registers don't need MSWin in it anymore. Comparing between two enums is a bit questionable. Well, they're just integers. See, this is 0. You may be right. It could be a terrible idea, but I don't see why. Because all we're going to say is this one is equal to this value. Have a separate scratch registers array. Then we have to build and free the array. It's a lot of work. But if we just had like registers for x86-64 MSWin, then we can have the ordering that we need. I guess we can't have the ordering that we need. So we are going to need separate enums for each platform, which means we're going to need, you know what I mean, separate register name functions, because all the enums are going to be different. The ordering depends on the enum values. Exactly, that's what I just was realizing as well. Like, dang it, that's not going to work either. It was a good idea, but it was a bad one because it doesn't work. And if they're the same as the main register enum, yeah, it won't work. So I'm just trying to avoid having to create literally a register name, like one of these for each one. But it looks like we're just going to have to, which means we might as well just keep the percentage sign, right? Because we're going to need one for x86-64 MSWin, and we're going to need one for Linux. I guess we could still ditch the percentage sign, have this at the top level, one for MSWin, one for Linux, etc. And then in each one of the backends, we could we could basically have the MSWin use the MSWin and the Linux use the Linux. Yeah. So let's just think about what does a Linux actually look like. So I think we're basically going to have like a CODEGEN folder, and then it's going to have a platform in it, and then there's going to be different implementations in here for x86-64 at least. So we're going to have like gas, and then we're going to have, I don't know, x86-64 gas mswin dot h and c, right? And then these are going to be included by all of the CODEGEN platforms, so we'll be able to call like CODEGEN program and whatever we need to call. So 8 says, my idea would be the following. I'm ready to hear it. Slap me with it. So then we can have like NASM and GAS and stuff like that, and FASM, and eventually we could have like WASM here and stuff like that. Just different platforms entirely. LandRXT says quickly sending, so there's a gap between the messages. Is that what happens on Twitch? That would suck. So if we had something like this, then everything would go in here. That is at least architecture dependent. So we have x86-64. I see, I missed a folder. Gas. x86-64. Gas. Swing. Yes. There we go. Okay. LanderXT says also WASM backend equals me making a website using this language for as much as possible. That would be awesome. I'd love to see it. Sorate says, I'd suggest having one register enum and one register pool with an array containing all the registers in order because the enum values are supposed to be indices into that array, and then adding a separate array to the register pool consisting of register pointers to the scratch registers in the main array. That feels so complicated. So what would it solve? We have one register enum, so we would go back to having this, is what you're saying. These are indices into register pool. That's what we have already. It's just using this enum. So we switch to this enum for the register pool basis. And then for scratch registers, that way we can have both of O of 1 mapping from register descriptors to the corresponding register struct as well as scratch registers in order. Okay, so we're going to have basically this be the main array, and then scratch registers will get their own enum and array. Am I understanding correctly? So each implementation will define its scratch registers. These will just be not taken into account, right? Only their own array. Because I guess we never need to compare scratch registers. But then how do we know? Am I missing something? Adderson says, hi Lens, hi chat, how are you doing? We're doing great. We're deciding to refactor CodeGen. For no reason at all, really specifically. The scratch register array is just so you can say, give me the next scratch register. Okay. So, if I'm understanding you correctly, adding a separate array to the register pool consisting of register pointers. So let's think about the register pool. So instead of having num scratch registers, you'd have, well, we may still need that. You would have scratch registers. This should probably be registers as well, but it's fine. We'll get there. Okay, we're gonna do it. We're doing it. We're doing it all. We're breaking the code. I don't see a reason not to. Okay, so let's do egg with code actions. Okay, we should be good. Adderson says refactoring day. Wow, this is great. Sorry, it says, okay, one sec. I'm gonna write this in code. Perhaps that'll be clearer. It's all good. So let's think about when we use register allocate. Yeah. We're just renaming some variables. Could probably just do a search and replace on regs for registers, but it's a little late for that. Alrighty. In CODEGEN context, we could now probably have a better name than registers, and this could probably be register pool. This will help us distinguish between these two in a more concise manner. Not concise necessarily, but I think clear manner. Cool. Okay, so this is what print registers would do. We can't use register, sad. So when we allocate a register, currently we just use num scratch registers. And then we use the register pool itself. But we would just use scratch registers instead. Is this the idea? So then how do you see how the descriptor gets an index into the next scratch register? I guess it doesn't have to be a descriptor in this case. This could just be an unsigned or whatever. So let's change it from D to I. I think that's fine. So as long as we keep track of the number of scratch registers, we won't overrun this array. Which is exactly how it worked before, just with the register descriptors. Then we say register pointer reg, if reg in use, reg descriptor. Basically, we get the descriptor from the register, and then during deallocation, okay, that doesn't seem too crazy. And then during deallocation, we just use the descriptor that we got and return it to the free function, exactly how pointers work. Okay, Sir Aid, I think I understand you. I think I understand you now. So now all we have to keep track of is the number of scratch registers. Order doesn't matter. Getting the register name, still we use the descriptor to get the name. So once we get a scratch register, we'll have the descriptor so we can get its name. We can compare the descriptor still. What's the definition of register pool now? Oh, I just changed names. Sorry. It's the same. I just added scratch registers as an array. That's the only difference. Does that make it 32 bytes? 16 bytes. That's not right. There's 2 pointers here. This is definitely 32 bytes. Very cool. Okay, I think this all works. I don't know if we need to panic here. We could probably return error, but that would mean we would need a buffer and everything, which just sounds annoying. Or I guess we could just set a pointer to the constant. Yeah, that also works. You still need it. It's right here. I do not want to jump away while you're still using it. Okay. Scratch register should probably be a pointer. You are correct. Otherwise, you're shallow copying the registers, which is not going to work, unless I'm reading this wrong. You're right. You are correct. I just was waiting to actually do it. No, I'm just kidding. I didn't know. I make mistakes. Just like, our friend, our Lord and Savior, Richie Stallman. You probably don't need a size T if you want to cut down on size. Oh, I'm not worried about size. I just thought it was interesting that it'd be 32 bytes. Because that's a very nice, neat number. I kind of like when things are 32 bytes. Or structures, and they're multiples of 2. Just makes it easy for struct alignment. And init registers has to set up the scratch register as well, in case you haven't already done that. Like when we create the context. Yeah, I think that's what you're referencing. You just have to say scratch registers equals a new array. And then we just have to figure out how many scratch registers there are. So let's link to MSDN documentation. Surely will fall away. It's been Internet Archive. That'll go here. So let me find some MSDN documentation that will surely go away. Okay. x86, 64. I guess they call it x64 calling convention. Okay, let's see what we got. Sir Aid says, oh, sorry, I meant CODEGEN context create. Yeah, not the macro, lol. I figured. So this page, terrible link. We're going to go to Internet Archive. And we're going to save it. See, it's been saved a lot. So it doesn't need saved. This is good, though. That means that we can just take one of the most... Can we save the page now? Is it somewhere here? It's got to be somewhere here. Web. No. Perfect. So now we're gonna save this page because I don't trust Microsoft. I trust the Internet Archive, the Wayback Machine, way more than Microsoft, which says a lot. But effectively, it states a bunch of stuff and tells us somewhere here, specifically, it's done. Perfect. So we're going to have here, and we're going to have here. Perfect. So now people can get to this even if Microsoft does its thing. Perfect. Perfect. Can I get a link to that? No, it doesn't work. Just curious. Okay. Anyway, we can see that RAX, RCX, RDX, R8, R9, R10, and R11. I'm also just going to quote this. Yeah. I don't know if we need all this. I think we're just going to take this. That's good enough for me. This should be enough for anybody to understand what the heck we're on about. Also, I just said heck. You might want to cancel me. 2, 3, 4, 5, 6, 7. Size of register pointer. So, I mean, it's just going to be a uint pointer t. Is that what I should do? How do you do a size of a pointer? What's the cleanest way? Should I just do this? Register pointer? I don't really like that. Maybe in this case, the star scratch registers would make a lot more sense. Size of register pointer is the cleanest way. All right. We'll do that then. So we want 7 pointers. And then num scratch registers. Gnarly Quack says, I personally like what you had. I don't know what I had. Gonna have to let me know. I've a goldfish memory, you gotta remember. Okay. So should we have like an add scratch register type of thing? Let's think about what the format is gonna be. So we're gonna need to assign some index to, what do we got? So it's gonna be basically registers. And it's gonna be the address. Here, we'll do this for now, just so it's understandable. And it's gonna be the address of the descriptor we're using. Is this correct? Whoa. Whoa. Ah, I hit Control G too fast. Sir says, when are we ever going to add scratch registers? Only here, right? So I think we can just initialize the struct directly. Yeah. Oh, can we even use your, like, fancy... Are we able to use your fancy syntax? I guess we don't have named things. No initializer lists for us. Also, let's just have size t number of scratch registers. Never be too verbose. Wrong argument. Move beginning of line. My thing broke. I can't duplicate a line anymore. Also, that's too many. You can only use initializer lists in C if it's a declaration. RIP. Gnarly Quack says, how big is register pool? Still 32 bytes. That beautiful, beautiful 32 bytes. It's 16 bytes because for some reason Clang thinks this is 32-bit. I don't know why. Clang is bad. Clang that's a Clang D, the language server. I usually do registers plus. Yeah, so I was thinking about that. Let's do that. If you're cool with that, I'm cool with that. Because I prefer that much better as, like, pointer arithmetic is fine in C. I just wanted to make sure that conceptually I was doing the right thing. So we're going to have AX, CX, DX, 8, 9, 10, and 11. I'm just asking because compound literals actually stack allocate. I've bitten myself before trying to initialize a pointer with a compound literal that ended up blowing my stack. That's crazy. Sorade says, yeah, and array index always seems a bit unnecessary complicated to me. Yeah, see, but in our language it won't be, because the index operator will be a pointer arithmetic. So this will effectively be the same as having the just array here. And then to actually get the value, it'll be a little more verbose, where you dereference the pointer. I think it's going to be nice. Also, I forgot to plus it. Okay. So these are all our scratch registers. There's 7 of them. And now when we're getting a scratch register, we use the scratch registers array to get a pointer like that. And then, so allocating, we just get a register pointer and use it. Did we do it? I think we did a slight do it. I think we don't need this anymore. I think after getting rid of this, it'll be kind of clear. We don't need this, right? Yeah, where do we... Okay. Count. Count. Yeah, we don't need that enum. Nice. The compiler will tell us if we miss something, lol. Hopefully. Or it'll just silently work until it breaks one day. It's my favorite. And effectively, we're probably going to remove all the percentage signs. Maybe? That means we're probably going to remove all the percentage signs, huh? So is this going to have to be in its own function? Or should all of these still be called for every platform? I guess we still have to make one of these for every platform so we can keep the percentage signs, right? Also, I gotta add gas somewhere in these function names. Okay. Yeah, I know. Yeah. He says line 99 is what I'm worried about. Let's check it out. Compound literal. See, I've never used these. I don't know what they are. So if they're unsafe and they blow the stack, let's just do this. Because I really don't care. Right? And in fact, let's do that. You don't even have to write those two. I think that's fine. And then, I guess we already have pool, don't we? So I just have to set it. And then here, it'll set it here. Pool equals etc. is perfectly fine. Yeah. I just want to make sure that, Gnarly Quack says we got stack issues. I don't like stack issues. I like the stack being stacked neatly. So I'll trust them. Because now we just have one stack thing. Rather than, I'm sure the initializer... Okay, so what he's saying is the compound literal makes another value on the stack. And it may clobber it. If pool is on the stack anyway, then you didn't need a compound literal there. You could have just used an initializer. True. I didn't write the code. So now we have a bunch of things saying, hey, this doesn't exist. Whoops. Not bad. I don't think this is ever going to change, but, you know, might as well assert it. Whoops. Register pool. Pool. Oh, we got some discourse on stack. Basically, there's an if-else. So we stack allocate the pool. We either say, okay, this is the first one, make it. Or we already have one in the parent, copy it. I think this is good. So if we could do this, is this possible? I don't think so. I think we have... See, we'd still need to cast it and have the compound literal. I don't know. I don't know. Sir 8 is correct. It's doing the exact same like move and shuffle on the stack if you look at the disassembly. Okay, I think I'm just gonna do this time. Coolness. Where else are we at? So if the result register is rats, lots of checks on that. I wish it was easier to search to the beginning of things with iSearch. Oops, nope, that's correct. R8. Okay, that's looking better. So now, if we think about it, we can use this enum in every single one of the x86-64 backends. We can also use these comparison suffixes. We can also use comparison type in just about any backend. So this should just go in codegen.h, I feel like. You know what I mean? I feel like that's the vibe there. Perfect. Types of comparison to be implemented by CODEGEN backend. Is that true? Comparison. CODEGEN comparison. I mean, technically, this isn't MSWin or anything. So foo f equals blah is not allowed, but foo f equals foo blah is. Sir, that is correct. A struct literal NC has to have a cast. Interesting. So an initializer list is not a struct literal, but a struct literal casted to a struct is, or register pool in this case. I'm just saying assigning from a compound literal is essentially the same as register pool temp equals blah 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 pool equals temp. Yeah. That's what's happening on both sides of the if, pretty much. Save R8 if need be and clear it. See, this can definitely be changed now. In any case, we can just allocate a result register. We can just reuse a register, it seems like, based on this. So we use comparison suffixes here. I feel like this could be for any x86-64, but it just will require different syntax. So it's going to be basically for every backend, but not Linux or Microsoft dependent. This is so messy. It's fine though. We're just going to make it Linux or Microsoft dependent for now. It's just going in the regular place. But we can take the set and use this everywhere. I don't feel like that's an issue. Something like that. Nope. Something like that. There we go. Doesn't seem too crazy. Also going to put these by the comparisons. Perfect. And then we're going to move the forward declare into where it should be. Alrighty. This can now be refactored. I mean, let's do it. What do we have to do? So our result register is this. So instead of doing this, what do we do? Save R8 if need be and clear it. So we don't need to save R8 if need be. We don't need to know if R8 is result. We just need to clear register name of expression result register. I forgot to feed it context. Is this correct? That's not going to work. It won't? So if we do this, we'll zero it out, right? I see, but we need to keep it. I see what you're saying. Because the result register is the left-hand side. Well, then we can't reuse one. We just have to allocate a new one, is all that means. And XOR affects the flags. Yeah, but we do a compare right after. So the compare will affect the flags and the set will deal with the compare, right? We just need to make sure that the children result register contains the proper value, which means that our result register has to be different, I believe. So now we zero out this result register. Yeah, that's why we can't put the XOR after the compare. Ah, I get you. Yeah, you're correct. Yeah, we can't do compare then XOR because XOR screws with the flags. See exactly what you're saying. So then we use the comparison suffixes, we deal with the thing. Instead of being R8B, it's going to be %S. Whoops, did I get rid of a... Oh, there's only one operand. Okay. I was like, wait, what is going on? So this is going to be register name, I think, byte register name is what I called it. I don't remember. Sure. Sure. And this is going to be expression result register. What? That's our descriptor, isn't it? Okay. So effectively, we get the byte register name. So this will set the 1 byte in the lowest spot. It's already been zeroed out. 64 bits. And then we deallocate the right-hand side and deallocate the left-hand side now. Deallocate left-hand side and right-hand side result registers. They are no longer needed. I'll just say comparison is complete. Move the value into the result register and store R8 if it was in use. So effectively, we were able to get rid of all this. Okay. So effectively, zero out result register. That's a lot cleaner. It really is. It's really nice. I like that all I had to do was make it so we can convert from register descriptor to a string, like a const char. It was pretty easy. I was like, ah, that's pretty dope. Do I return a const char, by the way? I'm not in that. Yeah, I do. I'm not in the habit of doing const anything, because C isn't really picky. Nice. Yeah, it's not perfect, but hey, this is a lot better. So now our cogen comparison is much cleaner. We have cogen function, expression, blah, blah, blah. And cogen program. So effectively, we're beginning to look a lot like Christmas. Everything is still working. And I think we can start to move some stuff. So we're going to have like a registers.h in x86-64. Right? Also, this is happening. I'm sorry. Not to be used. Used when initializing register arrays for register pool. Register arrays for register pool. That's good enough. Sir Aid says, also, maybe I missed it, but did you see the message I sent earlier about having a separate emit add x64 function, etc.? I didn't. Okay, so emit add x86-64. So I think what you're saying is that instead of, so in our binary operators, Gnarly Quack says, oh god. Anyway, I didn't even mean to spam chat too much. I've actually got to run though and just wanted to say hi. Have a good rest of stream, Lenzer and chat. Thanks for coming out, Gnarly Quack. And don't feel bad about spamming chat or anything. The more chats, the better. But yeah, thanks Gnarly Quack. Have a good day. Have a fun time. And we will as well. We'll do our best. So maybe have an emit. My favorite comment for situations like this is, if you have to ask what this is for, don't use it. Lamau. Okay, so effectively, I think what you're saying is that x86-64, we could have like emit instruction, and then we could just implement different emit instructions. I'm not sure exactly what you're saying with the emit add x64. Because we have an add here. I mean, we could put this into its own function, but it doesn't really matter. Right? It's just a few things. We could definitely refactor it, but it's not, it doesn't change functionality, right? That's just styling. Arusia says, beginning to look a lot like Christmas when it's not even Halloween yet. Lamau. Just wanted to know what your opinion on that is. Saraid says, I mean, one way is to go full abstraction and have an emit add x64 function that emits an add instruction with the right syntax for the right assembler. This is the message I meant. So I think what would be, okay, what you're saying, instead of doing printf, we'll do femit, right? We'll make femit, file emit, and we'll do x86-64 instruction. And we'll emit into the file code, and then we'll have a mnemonic, right? We'll have a mnemonic, or this could be an enum, but we'll have a mnemonic, a first operand, which would be register name, blah, 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 right? Or whatever. And then this. Is this what you're talking about? Oh. So we could have something like this. Something like that, basically. The way the logic that generates the code and the code that writes it to a file could be separate. Okay, so what you're saying is, instead of having femit write to a code, we would have emit and it would return a pointer. Like this? Am I correct? Am I missing the point? Sir Aid says, it'd have to be a variadic function. I don't think it'd have to be variadic. So we'll do 2 operand, right? Something like that. The point is that you shouldn't care about how assembler X would like the add instruction to be written. Right, we'll just have this function deal with it. So if we do femit into code, I think that's fine, right? Just emitting into a file the proper way, because then we can still basically just use fprintf in this exact same way under the hood. Yeah, that's what I meant. Okay, you should just be able to say emit and add between these two things. So we could either have this be an enum or a literal instruction mnemonic that we pass to the assembler. You know what I mean? But we'll have to figure it out. Let's think about it. Let's go write it, right? There's no reason that we can't have fun. I wrote this in a weird spot, but it doesn't matter. Basically, the instruction should be an enum. Alrighty, that means we're going to need literally every assembler instruction we use inside an enum. That's fine. That's fine. I'm cool. It's fine. So we have like enum x8664 instructions. Did a capital. I should probably do a capital everywhere. Or not capital everywhere. Kind of bothers me that it changes. Okay, so then we'd need a bunch of instructions. These are all capital. Why not? We'd have add, and then we need some way to convert these in a switch case, like into a string, based on assembler, right? Is that what you're saying? So we'd have like add, sub, blah, blah, blah. Yeah, basically. So why would we use an enum when we could just pass the string itself? Are they different between different assemblers? They're always the same mnemonic, right? The mnemonic never changes? Am I incorrect on that? I guess CQTO, you said that they use CQTL or something. The mnemonics can be different. Well, okay, then we're doing this. Rip. Add sub mol imol div idiv push. What else would we need? So to do, all instructions we use in x86-64 should be in this enum. And then we're going to need a char pointer, probably a const char pointer, which is going to return x86, basically instruction name, which takes in the instructions. x86-64 enum and instruction. And it's also going to need a CODEGEN format. What is it called? Where is it? CODEGEN output format. Arusius. Ooh. Okay. Also move Q and move Q word in friends. Yeah. Okay. Oh, I get what you're saying, Sarade. We're in it. I get why this would be done. That's why I'm doing it. If I don't understand why something's done, I don't start doing it. I get why we're doing it, I just don't get how. Does that make sense? Gotta love these nested switches, huh? What are the output formats? Okay, so this is a switch. I suppose you could have an femit instruction x86-64 gas, etc. Yeah, we could. I don't think we need to. Couldn't the nested switches just be an array lookup table? What does that mean? I don't know what that means. So in instruction, we're going to have to basically say every instruction we use. Also Arusius with XOR, compare, call, and ret. Thank you. XOR, compare, call, and ret. And yeah, it could just be a lookup table, not a switch case. Well, that means we have to build a lookup table. Are you serious? We're not trying to be efficient. We're just trying to get this done. Stop bike shedding. You're just saying, oh, you're making progress? Stop that right there. You can't make progress. You can use a struct literal. Oh yeah. That sounds great. Gnarly Quack will be very appreciative. Static const chart instruction mnemonic cogent output format count instruction x8664 count. That sounds like so much work. Why can't we just use a jump table? So you're saying... So it says const char pointer instruction names, which is an array, add sub, etc. But then they all have to be in order. This is terrible. Unless you can do... Okay, here's the thing. What do you want me to do with this array? I'm curious. How do you want this to function? We need to get these names all throughout the code base, no? We need to call this all the time? So where are we storing this array? Where are we magically allocating it? I'm curious. I understand you can make an array and make this a lookup table, but I'd love to know how. Where's this array go? Because we don't just want to build it every time. Sir Aid gives an make it a global constant. Oh Christ. Okay. Add. And effectively, this is going to return add. Complicated one. And effectively, we could also just do a switch on format and handle things that by default breaks. So instead of, I mean, we can return add in these cases, but if we default to a break. Okay, so thinking about this, we have an instruction, and they might be the same in multiple formats, because we're going to have like x86, 64, right? So our format is going to effectively tell us, sorry, it says, or just make it static. You could also just generate the lookup table and the enum in one fell swoop using a macro. Yeah, it's not my style. I'll do this. If you want to implement it and make a pull request, go for it. But yeah, that's not code I want to maintain. This is at least understandable for me. So we switch on the format. And in the default case, not in the default case, in every case, we want something to happen. So I guess we should switch on the instruction first. Why are you mad? And then have the default be break. Handle all instructions that are the same across x86, 64 formats. Okay. Okay. So it says right now or later? Probably after I commit it, so that you can change it. It's up to you though, if you want to deal with merge conflicts. If you want to merge all this, you can do it. So I'm just trying to think how to not like repeat add and sub here. So effectively, we're going to have so it's like each instruction should switch on the format instead of the other way around. Okay, I think that maybe kind of turn it inside out. I think this makes somewhat of sense, because in the case that it's this, also this is for x86 64 obviously, so the format is just telling us, yeah, let's think about this. We can switch on the instruction and do all x86 64 instructions that aren't different across syntaxes and go here. This may have to be not cogent output format, but something else. We'll figure it out. Sir Aid, how to not repeat add and sub here? It sounds like you want a macro. It doesn't. You can try and convince me with your predetermined perspective on macros are great and that's what we should use right now. It's not going to work because that's not a reason why. x86, 64, that art different can go here. Perfect. x86, 64 instructions that are different can be handled here. So switch on the instruction and then switch on the format. Should probably just panic here and say, hey, could not convert instruction into mnemonic or x86 64, something like that. Erusius, couldn't you then just combine these two switch instruction statements into one? No. Maybe. Yeah, we probably could. Because we could just have switches in the certain cases. Yeah, see? Erusius. Great idea. I like how you think. See, Erusius, you just saved me from overcomplicating it. I'm very good at overcomplicating things. You saved me. Whoops. What else do we got? We got push and pop. Soda pop. Okay, push and pop. We got XOR and compare. XOR, pretty sure those are the same. Call. Ret. And that's all we got for now. And we'll just do an asserty malerty that instruction. Well, no, we'll do instruction x86 64 count is equal to whatever it is, 12. And then we'll say, hey, buddy old pal. Okay, instruction x86 64 count. And say instruction mnemonic x86 64 must handle all. I don't like that I'm going to do it as part of the message. Must handle all. x86 60 all I don't even know what to call those. All instructions. Exhaustively handle all instructions. Okay. Okay. I think this isn't too bad. It's a good start. And for our emit instruction, right? Did I start writing emit instruction anywhere? I probably didn't. So emit instruction. Let's think about this. Or we could just get a string back, but I don't really want to do dynamic string allocation for CODEGEN. Where's that thing? Wasn't I writing something? I was like femit. Yeah, here. So maybe let's just write this. Sir Aid says, that reminds me. Femit. I should probably make a commit soon also. We're just going to do void for now. We're going to take a file pointer code. We're going to do what? femit x86-64 to operand instruction. So we're going to need an instruction. And we're going to need 2 operands, right? We're just going to make strings. So we're going to call this the source, and we're going to call this the destination. And then we're probably going to need the format. I forgot to put space. Okay. For stuff like this, which is known at compile time, you could also use static assert, or maybe have a static assert. Isn't that C17? Or maybe have a static assert macro that conditionally maps to assert if you want to support C standards before C11. It's probably C11. All right. Sorry, it says C11, not C17. You right, you right. So for stuff like this, which is known at compile time, you could also use static assert. Yeah. Basically, I would do that in C++, but I'm just not in the habit of it in C. So switch on format. I know. Jump tables, baby. And in this case, we don't need a return. It's a void. So in this case, default, we should probably just say like wrong format, right? I don't know. So for x86-64 MSWin, we're gonna have to add gas somewhere here, right? MSWin really isn't even part of this, but sure. MSWin is really a calling convention. We should really separate calling convention from this. Okay, but that means that we're gonna need like CODEGEN calling convention, MSWin, Linux, etc. And that's gonna have to be used. We're just doing the biggest refactor we can right now. Figure the more we break, the better, right? Sir Aid says underscore static underscore assert probably always works, I'd guess, because that's the actual keyword. True. There's a lot of like underscore intrinsics built into compilers. It's kind of crazy once you start learning about it. It's like, oh, all these functions can just be called at any time. Crazy. So we're going to change it to gas. And then we're going to have a calling convention. Which, yeah, probably could be part of the format, but I think it's different. It's going to be passed around. Underscore underscore is my favorite. Lamau. Yes. Okay. Okay. So given that, we can now say in gas, printf into code, returning what? So this would be SSS. And this is going to be effectively source destination following our instruction mnemonic x86-64 of our instruction in our current format. Whoops. Hey, built-in stircher, etc. are pretty useful in C++ because they're const expr. It's true. The compiler knows that they are what they are, which is pretty dope. Pretty dope. So in gas, it goes instruction mnemonic, source, dest. In not gas, it would go instruction mnemonic, dest source. This is only a one operand. I think with a single operand, we don't really need this, do we? I mean, we don't need the format. We just need the instruction, the operand. Still a little long. I think that's okay. Yeah, that's okay. And then basically a one operand instruction. I guess we still need the format to pass to instruction mnemonic. Pull up. We just need one operand. And we don't care about the format here. Okay. Okay. Does this make any sense, by the way? Am I going crazy? We could do emit 3 operand, but I don't think we use any 3 operand instructions, so we're not going to do that yet. And yeah. So with that, we now have our output format. We need our calling convention elsewhere. In one case, the registers are written with percentage, and in the other case, they aren't. What? Yeah, that's why we just take in strings here. That's already handled. Don't worry about it. I mean, we could just do this and then remove all of these. Is that possible? I mean, we still need to set these up. So it doesn't really matter. Because each, like MSWin and Linux will need their own register pool because that contains scratch registers, which will change between platforms. And calling conventions. Sir Aid says, also some instructions need special formatting like Leah. Exactly, that's why we just take in strings. Okay. So now, effectively, let's look at femit and think about what it could be. It's an add instruction. And we have source into dest. So which one do we use? Use right-hand side as our result. So this is our destination for sure. So we need to pass what? The instruction. Okay, we need to pass the format first and then the instruction. Do we have our format? Is question number 1. The answer is probably no, because we already handled it, quote unquote, right? So currently, this is only MSWin because of our external function here, right? So this is the only thing in the world that makes it MSWin. So I think we can remove MSWin, switch on calling convention here, and then not really have that big of a deal, right? I suppose storing the format in the context is an option. I don't know what that means. Arnow 478 says aluminium. What's up, Arnow? That's right. If anybody doesn't know, the first time you use the compiler for good luck, use that -- aluminium flag. It'll help you out, I promise. Okay. So effectively, what we would like to do is what we would like to do. Let's think about this. Cogen context, x86-64 mswin create. This is for sure mswin. That's all valid. That's for sure mswin free. Yep. Baller. Totally. Sir8 says, what I mean is you could have a struct member in the cogen context that stores the output format. Ooh, okay. Thank you. That's smart. As well as calling convention, I guess. It's kind of annoying, but it's okay. Because we need output format and calling convention to be passed around. And they'd also have to be shallow copied along with the register pool. Why not? Sure. Is that too bad? Okay, then in cogen.c, mswin create. Yeah, format equals, I guess no matter what, we can just set format to it. Also, it's kind of weird that locals and locals offset got so separated. Arnell says, is the fun compiler only for MSWin, or will it be available for Unix-like OSs, Lamau? Arnell, I love you. If not, are contributions for that accepted? The compiler is completely, it runs on every OS. This is just the output format of the programs that it compiles. And we're removing MSWin because I was just on Windows, so I was writing assembly specific to Windows as I started. But we've removed all of that specific assembly up to a certain point. So now we're going back and making it cross-platform, even the output code when there's external calls and stuff. Arnell says standard lib and all? What? I don't know what standard lib and all means. But effectively, yeah, we only use the standard library. There's no third-party dependencies. So the C library is all that's used, the C standard. Sir Aid says, or I suppose it will once the support for sys5 ABI is implemented properly. Yeah, and we're very close to that. We're about 25 minutes away from that. Can guarantee you. So every time we set up the context, set up the locals and the locals offset, we'll set the parent first, set the register pool, and then set our format, which is going to be equal to cogen format x86 blah blah blah. The other one. Context. Call convention. Do we need format like this here? I don't know if we need this here. We may just need the calling convention. Let's try it. And we'll make this cogen call convention. Okay, okay. So now the call convention, every time an MSWin is created, I think we do need the format as well. Okay. I trust you. This is a blind trust right here. Cogen output format. But you're probably correct. We're gonna get later and go, oh, we do need it. So do we know the format? This is for x86-64, right? But we don't know the format. See, when we create a new context, it could either be for gas or for NASM. This one is for gas. So this is gas MSWin. It's almost like we should have, I mean, yeah, they're gonna be different bodies, so these aren't parameters. Hey, look, thanks. CODEGEN format, that's format. So this is gas MSWin, x86-64. Yep. Okay. Okay. When did we need the format? We needed it an femit. We do need the format for femit. Thank you. So CODEGEN context format. So maybe we just pass the CODEGEN context. Does this make any sense? Passing the context here? Or should we just pass the format and the call convention specifically? Just pass the context, so it says, okay. Let's call it context. Really doesn't matter, because we're not dealing with anything. So switch on context format. We'll take a pointer to it, because why not? And we'll say if not context. We're just going to assert context. Yeah. We're just going to assert context. Any programmer will know. Okay, it's null. Passing the context as like the one thing that contains everything, and then each function can just grab what it needs, seems like the simplest way to me. I think that's correct. It's very similar to like a private member in a class in C++, which I think is effectively what we're mimicking here, which is cool. Why are we mad? Why are we mad? Because this is a const char pointer. It's not always a const char pointer though. So these are cast. That's kind of annoying, but it's fine. So it says, yeah, basically, the context pointer would just be this pointer if this were C++. Exactly. You're exactly right. We would just pass one to our member. You could even store the file pointer in the context. Ooh. I like that a lot. I like that a lot. You just opened my mind up. So, do we do adding in the pointers example? We don't do any adding, which is probably good. We don't have any math. I'm just gonna put in, see, still no adding. We're just gonna do simple math. 4 plus 4 plus 4 plus 4. Oh boy. See where we went wrong. x86, 64. Okay. I know what we're going to have to deal with now. So effectively, we're going to have output formats, but we're also going to have calling conventions. Right? You could have just make the parameter a const char, but it won't always be a const char, is the problem. Because in CODEGEN.c, there are times with 2 operand instructions, like in reassignments with lie, where we use a heap allocated buffer, result, which is a char pointer. I don't know where that is, but it's somewhere. Here we go. Right here. I guess we could cast that to const, but we'll see. You can still pass it as a const char. That's so bad. Doesn't that lead to const contamination? That's what I was thinking. Like, I'd rather lose a const into a char pointer. I don't see the reason to keep it a const in the parameter. Other than not having to cast, obviously, but... Constamination. Casting to const is implicit. Is it really? That's so gross. Well, that's the whole point of const. Is it? It says that the underlying memory shouldn't be changed or whatever, is what I thought it was. Where is char pointer? Where'd it go? Where'd you go? Whatever. Arnau and Brainsman are both saying const should not be used. What do you mean by const contamination? I see. Suraid says. I'll let them explain. The function doesn't modify the string, it should always be a const. That's C++ thinking, yes. But in C, const does not mean constant. As I continue my C journey, I know I now need a lesson on device files. I mean, that's not a C journey, that's a Linux journey, my guy. That's Unix. You can interact with Unix from C, but you have to use their C library, or their syscalls. Suraid says, it is, and I'll admit that I'm more of a C++ programmer these days, but still. Yeah, I'm siding with you. I don't want to do the casts everywhere, so I'm gonna have it a const, even if it has const contamination, but it's not a problem. It's really fine, because there's only one situation in which we ever do it, and we actually free the result right after. Everything's fine. This is fine. Okay, so we still have some issues. Oh yeah, because we need to handle main and arguments properly now. So we're going to have format, then we're going to have calling convention. I think that's fine. Maybe like that? That doesn't seem too bad, does it? Dash dash calling. Should we have dash dash calling convention? That just seems so long. No one's ever going to use that. Maybe we just don't have a long one. I don't know. How are y'all feeling? King Bun says, yes, that is indeed Unix, but I feel like by working with Unix, I will gather a deeper understanding of C in general. Maybe. Unix is definitely its own beast. Brainsman says, I mean, Suraid is right. If you're only reading from the pointer, it should be const, but if you want to use this argument in another function, that function can only take const char pointer, not just char pointer. Now you have to either cast it back or cry because you contaminated your pointer with const. Exactly. Effectively, by consting something, you can never unconst it. But in this case, it's okay. Maybe just dash dash calling? Okay. Whatever feels right. I figured I'd let chat decide. Set the calling convention to the one given. And then this is just going to be callings. I know it doesn't make the most sense, but it doesn't matter. You can pass a char pointer to a const char pointer parameter, so I really don't see what you're on about. I see. So we're talking about passing a const char pointer. Once you've passed that char pointer as a const, you can't then pass that const char pointer as a char pointer. See, Brainsman, yeah. Brainsman had it right away. With the quickness. Formats and callings. Yeah. Print acceptable formats, x8064 gas. And really, eventually, we should have formats separate from platforms, but we're not going there yet. Print acceptable calling conventions. I guess it's LMNOP. We'll just go alphabetical. Brainsman says, even more than a bad idea, it's a compiler error. Responding to Storade, of course not. If a function takes a char pointer, that means the function will modify it. Passing a const char pointer to that is not a good idea. Exactly. Brainsman says, the thing is, if you use the standard library a lot, you'll see a lot of function only take a char pointer, even with no modification. That's very true, which can be very annoying. Very, very annoying. So, print acceptable formats, print acceptable calling conventions. So now in the case of formats, do that. In the case of callings, do that. I guess I could continue and set a flag that says exit, but we'll see. Okay, so now this is format. I don't know if I like these being globals, but it's fine for now. I don't know why I need output either. I could just call it format. CODEGEN.h. Did I not make a default? I didn't. Default, which equals call conv mswin. Why not? Okay. So effectively, what's your issue? Oh, so now we have CODEGEN calling convention. And we'll add it in even though it's not handled yet. Okay. Expected calling convention after calling convention command line argument. Instead, got an unrecognized format. I don't really like this. How can I do this? I'll just leave it long, who cares? Instead, got an unrecognized format, or did I? I think that's pretty good. Okay. So with our calling convention now able to be modified from the command line arguments, we now need to pass that here. Like this. Okie doke. Okay. We're getting closer. Remember we had like hundreds of errors before? Cogent context, x86, gas, MS-Win. Cogent program. If format equals gas, then basically this is where we're going to call the different function. So this is going to be gas. And it's win create. So to do handle call convention for Windows, Linux, external functions. Not for that. Handle call convention for creating CodeGen context. And then I think we can use the context that we create, right? We're basically going to say, okay, we have this pointer. If, what is it? Call convention is equal to CG call con MS-Win, then we want to say the context is equal to this, else, and then basically say else if blah blah blah. For Linux, to do handle Linux ABI, create CodeGen context for Linux. Sure. And then we'll do like a return error here because we have error to do. We're going to say, hey, create CodeGen context for gas, Linux, x86, 64 assembly. All right. Ooh boy, lots of discourse. King Bun says, I am still trying to fully digest C pointers, so please correct me. They aren't really considered a type, which is they aren't written as char pointer. Instead, you are declaring that the memory address has a character. Pointers are a type. It's just that if you have a character pointer to foo, you can think of it in two different ways. Foo is a character pointer, or a pointer to foo is a character. Dereferenced foo is a character. The main reason why C programmers prefer to put the star on the right is because if you have int pointer p and then q after a comma, then that's int pointer p and int q, and not int pointer p and pointer q. That would be int pointer p and pointer blah blah blah. Brainsman, Yeah, I believe they all are, but even with some of them written with the... Okay, he's talking about string.h from earlier. Sir Aid says, putting the star on the right signifies that it's part of the declarator and not the type. C is a lot sloppier about const in general. In response to Brainsman, Sir Aid says, simply because const was originally a C++ thing. Basically. King Bun, so is the benefit more readability? Like you are more idiomatically stating that when you dereference foo, like in the context of dereferencing foo, you will get char. So char pointer foo is a little more informative to write. Basically, yeah, it's mainly, it's just because in C, a pointer is like a modifier on an existing type, but you can think of it as its own type because it has its own like semantics with pointer arithmetic. Wait till you discover the terribleness of T array n arguments. I don't know what that is. I guess it's also preference. Surrayed is absolutely correct. Nope, char pointer and int pointer are not the same thing. Responding to King Buns. What? Yeah. Since they also support pointer arithmetics. I see what you're saying, yeah. So pointer isn't its own type. Pointer contains another type, and that is a different type within itself. So a pointer to a char can be thought of as its own type, or you can think of the type as a char, and there's certain amounts of indirection levels on top of it. Okay. Else. Error prep. Error generic. Well, you know what we'll do? We'll just say assert that cg call conv count. It's a lot of work. Let's do this. I mean, we could say, well, what's the maximum? But we'll just do like an else and say, hey, I don't know what that is. Error, generic, unrecognized calling convention. Okay. Whoa. I guess we return error down here, so it doesn't really matter. So then this can be x86-64. It's just going to need some things. So CODEGEN function gas. There's nothing about this that's MSWin in any sense at all. Nada. I mean, there's the external function part, but that's just a declaration. Oh, that's in CODEGEN program, which also is not MSWin at all. So now our CODEGEN context contains everything we need. Also, I'll get rid of this double window thing. Sorry about that. Eternal Wildfox says, hell yeah, I got a CMake install with fetch content going. Oh man. Oh no. King Buns is starting to understand pointer arithmetic. Brainsman says, int pointer, char pointer, long pointer, pointing to a defined type with a pointer arithmetic that goes with it. Void pointer, char pointing to anything with no arithmetics. Yeah. Okay, so our context contains everything we need. So CODEGEN context gas MSWin create. See, so this function we're gonna have to call differently based on which one we're in, right? So we're just gonna basically say if context, nope, CODEGEN context call convention is MSWin. Not quite. Do this. else if blah do other thing. That doesn't exist yet. I think it's not really too big of a deal to handle the calling convention when creating a new context. Creating a new context isn't done all the time. It's kind of a very specific thing. Okay. So, -win. See, I think we can just cogen the expression regularly. Oh. We sure do call this function a lot. Perfect. Suraid says you could also make a duplicate cogen context function or something because the context contains the calling convention. Oh, Suraid. Oh my god. You just blew my mind. You're like, oh, wait. Yeah. So CG callcon. So basically, duplicate cogen context. So cogen context equals create new from. Yeah. Okay. Where would this be? Probably in cogen.h, right? We're gonna have a context. We're gonna have to create it. Let's think about this. So we were going to want a cogen context pointer, right? Or like cogen context. Return context. Context equals calc1 size of cogen context. So, and this is going to have a context. So the context we pass, do we want to just pass a pointer to it and edit the context? The alike is funny, but do we really need it? I mean, create cogen context, I agree, would also work. I'd do create alike cogen context. I don't know. We'll just keep it create. We'll keep it simple. And instead, we'll say, well, let's think about what we do normally. So normally, what do we have, right? We say, we pass in the parent. So let's pass in our parent. Let's name it the proper thing. Doesn't cogen context xx create already allocate the context? Ooh, you're right, it does. Because this calyx itself, we don't pass it. Okay, and then we basically just have to say, pass in the parent here. context. What's the issue now? What do you return? Implicit declaration, because this is, yeah, that's okay. Okay, I think that's where we're at. And then we'll just assert. We're just gonna go do it. Count. CG call conf count equals 3. What is it? 0, 1. That's 2. Okay, so I got to do that. Good enough. And then it'll equal 2. And say create CODEGEN context must handle all calling conventions and formats. Yeah, why not? There's a lot of great discussion going on in chat right now. They're talking about const tags in C, C++. It's really cool. Handle all CODEGEN formats. Must exhaustively handle. Yeah, why not? So switch on parent. Create child context, because we can't create a new one with this. So parent cannot be null. Lots of asserts, but I think it's beautiful. Okay. So if context format equals CG X format, yes, create these contexts. Does this make any sense at all? I think it does. Yeah, I think it makes sense. Okay, so CODEGEN context parent. Why we do these things. So it's not showing trailing white space. There we go. Sir Aid says, I love how you sometimes use small x and sometimes big X, lol. Damn it. That's horrible. I'm so sorry. It should be small x everywhere, ideally. But it's not here when I wrote these. Lamau. It doesn't matter. It does matter, but it doesn't matter right now. Okay, so this should be panic unreachable. did not handle, did not create a new context from the given parent. Sorry. We're gonna just return to make the warnings go away, but unreachable. So now, when we create a CODEGEN context, we're gonna have to actually somehow know how to create it. So, create. Okay. We could also do a free CODEGEN context in a similar vein, but we'll see how it goes. Okay, so we can now CODEGEN context. This should work. Hopefully. Yeah, nothing else is really dependent on MSWin or any format, except for GAS, which is why this is the GAS backend. A gassy backend does not sound like what you would want, but I was drawn to it. Nearly there. Where are we at? CODEGEN comparison. It says it doesn't exist. So the idea is this won't matter eventually. While expression and error equals CODEGEN expression x86 64 MSWin. That doesn't exist. That doesn't exist. Oh, hey, haha. Assertion failed. CODEGEN format count equals 2. Okay. It equals 1. That's fair. I just copy and pasted. Oh my. Wait, did it work? Chat, it worked. We're back. It's up and running. Oh my. Okay, so we still have more to do. Sir Aid says, I did something. You did a lot, Sir Aid. Without you, I don't know what I would have done. Okay, so really we don't even need gas here anymore because we can switch on the format we are given. Or use a lookup table eventually if you would like to refactor. But for now, this is going pretty good. Okay. Okay. So when cogening expressions, we no longer want to use this, and we'd like to use femit. And we'd like to pass code, context, instruction. So which instruction is this? What did I make? What did I call the instructions? Here, hold on. Instruction underscore x86 underscore 64. Okay. Move. What's the issue? Oh, it's this. No? Did we not do move? We didn't do move. We literally forgot move. Lamau. We may need more semantics around move in the future, but for now, this is what we're going with. So then the source, we would like to move see, we're moving into this register name, but from a literal. So we're gonna have to use like sn printf into a buffer and everything. Man. I don't like doing this. So maybe we could leave this one on its own, but we can't because that's gas syntax. Does anybody... I would make move immediate to register a separate instruction. How would that help, though? Why? Because move is really like 6 instructions with the same mnemonic. If you can tell me why, I'll do it. I don't understand why. Because all we'd still just need to output move, and then the source operand has to change. Source operand is going to have to be some string. Source operand. Right? Source operand, sure. We'll go integer literal. That way you could do the printf with the immediate femit. But then I would have to not pass a string as my source. My left-hand side would have to be an integer. You could make it a variadic function. That just sounds like it's complicating things. And then the type of the operand would depend on the instruction. We can try it. So basically, if it's variadic from this point onwards, right? So you're saying instead of having const char blah blah blah, we just have dot dot dot. Then what do we do here? Right? I have to use like VA list and VA start and VA end. The C way, I guess, would be to make femit variadic. So it says yeah. What were you saying would make variadic? So if we make this variadic, then what do we do now? We have to do like VA list, don't we? Args or something, and then VA like start, VA start. Then you don't even need to have separate functions for 1, 2 operands. All right, it's true. So then how do we detect how many operands we were given then? And how do we detect what type they are? Magical man. VA start args instruction. Nice. So VA start. So this just tells us this is the list we want to use. And this is we're going to have to include standard arg, I know. And then we have to VA end. Is that VA end? It is. The number of operands depends on the instruction. Alrighty. But doesn't that mean we can't just do this? Doesn't that mean we have to code gen literally every instruction in here? The caller is responsible. Yes, but doesn't that mean that we have to handle literally every instruction right here? That sounds pretty not cool. That way everything would be in one place. What? So you're telling me that what you want this function to do is decode every instruction and then emit that into a file and handle every both GAS, NASM, FASM, etc. of all x86 64. So RAID says yes. Alrighty. If that's what you're saying, I guess we gotta do it. It could delegate to separate functions. Yeah, it still doesn't help that much. It's still just as complicated. Like putting this switch inside a function effectively. Okay. So now let's just handle all our instructions. Like literally every single one. And we're also going to need move, register immediate, move, I guess immediate into register. Move immediate into mem, move mem into register, register to mem. Are all of these allowed? But having an f-emit function that you can just pass an instruction in operands would be nice, I think. That way you don't have to care about how to format it. You can just say emit and add now, and it'll do it. Yeah, you're true. You're right. You're right. It's a nicer API on the surface, but the lower level is harder to implement. Immediate reg, immediate mem, mem to reg, reg to mem. I think that's it. Move immediate to mem. That's the one I was like, I'm not sure if that's even possible. We'll leave it in for now. In any case, like literally, in any case, just return move. I don't really care in this situation. Sure. We got a link to Felix Cloutier. I'll always click these. So move register or memory to register. Register or memory. So we need move reg to reg, of course. So move reg, move register into memory. So reg mem, reg. Those are the two I see so far. We have R8 into, yeah, R16, sreg, AL, immediate. Yep, you can move immediates into memory. So immediate to memory, immediate to reg. Can you do memory to reg? It doesn't look like you can do memory to reg. Oh, you can here. Yep. So we're good. I think that's it. Right, it says, I guess move reg is missing. Yeah, that was pretty funny. You can do memory to reg. Yep. Right here. Memory to reg, register to memory, register to register, immediate mem, immediate to register. That's why I said move is like 6 instructions. It's at least 5. What is it? Reg is what we forgot. Yeah. So it's unhappy. I forgot. Oh god, I forgot. I totally forgot. Other instruction sets, load, store, etc. x86, 64, move. That's right. Just one move. Okay. So I have to use... oh yeah. So VA start, I have to access my arguments. I have to give it a type, don't I? So in the case of... Oh, Christ. Move register to register. Then they're both going to be strings. Do I just do this? Is that how that works? Char pointer. Yeah. Okay, Suraid, thank you. VA arg, args, char pointer. Wait, is it instruction? It's args, right? Whatever I called this. Sorry, VA args, args. Okay, Suraid, you right. Just making sure. So register to register, they both strings. And we would like to use 2 strings. Okay. So alrighty. We're gonna have to support all of these, so we should assert as well. I don't know, 15, whatever it is. FEMIT x86-64. Must exhaustively handle all instructions for GAS syntax. Okay, so in this case, since we know we're moving register to register, we could also put in, you know, our own parens. It'd be pretty easy. So let's think about everything that'll have strings. I'm pretty sure almost everything. I recently had to use libcurl. Sir Aid says, I recently had to use libcurl for something, and curl setopt is a similar variadic API, so I guess that is what made me think of this. Awesome. Honestly, curl is pretty dope. I like curl a lot. I don't think that's too insane. We could like use uint64t, but it really doesn't matter, or int64t. I think we can just use long. Well, it's not going to be 8 bytes everywhere. I don't think it matters. We'll just go include standard int. Why not? Okay. And then we'll see this is a long. So we can't really format a 64-bit number, can we? Isn't there like pry64 or something? Or px, pr. I remember something. Also, maybe you've missed it, or maybe I missed you reacting to it, but we were talking about putting the file pointer in the CODEGEN context as well. Yeah, we're gonna have to use the PRI stuff. PRI C, standard int. Here we go. Pry D64, okay. PRI, and it's in int types. A, B, C, D, E, F, G. Okay. Why are you mad? Format specifies type char pointer. What? No. Is this fine? I feel like this is just ClangD messing up. I'm just confused why it thinks it's a problem. 16 enumeration values not handled in switch. Oh yeah, we're getting there. So moving a register to a register or register to memory. So memory. I guess that would be what, something like this. Move register into memory. Yep. I've also figured out something that we can simplify. Mnemonic. You could probably just pass context to mnemonic as well. Okay. So we print our mnemonic. Why is it blue? Excuse me? Hello? Why does it want an extra... What am I forgetting? So it's saying mnemonic isn't a char pointer? But maybe it's like pry-d64 is very incorrect. Expand macro VA arg. Oh yeah, that's what I want. Jesus Christ. Maybe it still thinks you're on a 32-bit system. That's probably what the Clang D is doing. You're correct. Sir Aid, thank you for that. You're so smart. I forget easily. So move register into memory, surround it with parens. Move memory into register. Won't there be an offset here as well? That should be like an integer? Because this should be a whole thing, should it not? So it's almost like we need to document what we need. So we need an offset. Okay, so this is again pry-d64. Okay, so we have mnemonic, VA arg. We have our offset. It'd probably be rip relative if you're moving to memory. Oh, that's a good point. So if we look at code.s and look at our moves that we generate, you're correct that when we move to, it's almost always rip addressed. See, sometimes it's not in rip. See, with dereference, we have to write into racks. So we are going to need not always rip. I see, yeah. Yeah, we'll get there. So this would mean that for register mem, you'd call femit ... but we would call it with what? Reg to mem, obviously. But following that, we would call... Okay, we want the left-hand side. So this would be register name of left. Then we would have offset, long int 64t offset. And then we would have source reg, dest reg, and offset. Yeah, I'm just having trouble getting them in the proper order. I'm going to have to do something like this. Left equals VA arg. And then I'm going to have to say int 64t offset equals VA args. Char pointer right. So this is, instead of left, let's call it what it is. So currently left would be the source, right? This would be destination. And then offset is going to be int 64t. Now you need braces around the cases because declarations. No, we don't. Fixed for you right there. Why, see, why? See, this is my little trick when it tells me I can't make things in switch cases. I just go, huh, watch, and do one of these. But it'll work, I promise. This should be good. So we have mnemonic, source, offset, destination. Why is destination upset? Data argument not used. Yeah, it still thinks I'm on a 32-bit system. That only works if there's no case before that. I'm pretty sure it's fine. Right? If there's no case after it. I mean, that also works. We still have to put in our breaks so that we don't generate all our code. I think it's fine. It's not really an issue. You just have to trick the compiler. Say, hey, let me do it. Okay, what do we have? Codegen expression. Move immediate to register. The immediate is going to be expression value integer. And then we're going to have the register name thing. All right. Implicit declaration of function. Perfect. Assertion failed in file codegen at 62. It doesn't equal 12. What does it equal? 17, because we added all the moves. And we handle all the moves here. Instruction count equals 15 at 131. Uh-huh. It does work. Maybe that's a C++ thing then. I mean, it still gives you the same errors around case and labels and says a declaration cannot come before blah, blah, blah. But it's totally fine. You just trick it with the if statement at the beginning and it works. I don't know why it works, but that's just what I do. So right here. Okay, we forgot new lines. That's a good sign. We're moving up in life. It really shouldn't work. That's weird. Yeah, it's absolutely like not compliant code with the C standard, but hey, it works. Move LLD racks. God damn it. Do we need a percentage sign here? Nope. That didn't work. What the hell just happened? How do we just move LLD? That doesn't make any sense. Ah! You might need a percentage sign. But then we get big errors. I don't know if that's correct. I mean, these are the proper types. This is the only place it's used. Visual Studio, help us out. Yeah, I just checked int types. It doesn't include the percentage. Aight. So, run. What are we trying to compile? Pointers example? That's what we're trying to compile here too, right? Yeah. And it works? It seems to work. We got all sorts of issues. Identifier undefined. Does it think this is C++? What the fuck? This is C. God damn, I hate Visual Studio. Are you passing the varargs in the right order? Let's see. We have an int and then a char. We have an int and then a char. I'm pretty sure. You could do a cast if you want. Still big error. Cogen.c. Yeah, definitely a C++ file. Good job, MSVC. For real. God damn. So this expands to LLD. So we do percentage LLD with a... Ah! This is so annoying. In call. F... What? Let's see, address of a string. Ah! Ah, maybe it's not where we were looking. Did we forget it somewhere else too? Yep. So there needs to be a percentage sign here. So we were probably clobbering the stack like that with the prid. Nope. Damn it. I was hoping. Yeah, still nothing, huh? Okay, so no really complaints here. Struct cogen context has no field format. What are you talking about? What are you talking about? The end if for this directive is missing. Okay, something's wrong in here. You can't have parens at the end of an enum? What about this one? What the fuck? Jesus, Microsoft, why? Why do you do these things? Regmem. I don't think we ever call regmem. So we only call immediate reg, because our femit is, there's two places where it's used, right? It's in the add. So maybe it's in the add. Maybe that's what's going on, because we don't handle the add. I don't know. We still just get exit with code 5 for no reason. And apparently it doesn't happen in Visual Studio. So you'd think an unhandled thing might do it, but no. So add... See, aren't we going to have, like, regmem for all of these? And by GDB, I mean the Visual Studio debugger, lol. Lamau. So aren't we going to have to, like, add immediate as well? As well as have, like, add reg. Is this also something that's going to happen? Straight says no. Why not? Does add always work on registers? That'd be kind of nice. The thing for move is that it has a different syntax depending on what you're trying to do. I mean, so would add if we're trying to read from a thing. Right? If we're trying to... Maybe I'm incorrect. Let me look. Should be right up top. See, because you can add immediate and add register. I don't think you can add memory to register. Well, you are incorrect, so you're a Sir Aid that doesn't help. You can absolutely add immediates, registers, and memory into registers. Apparently you can. So this little syntax, this regmem thing, is going to have to be a separate thing with the instruction. Basically going to have instructions x86, 64, but these aren't going to be just instructions. Jesus. These are going to be instruction operand. Instruction operands. I don't really know what to call it. So we're going to have immediate to reg. I don't know. Immediate to register. Register to immediate. No, that won't happen. And mem plus immediate, now that I think about it, because the variadic parameter is going to be an int, not a char pointer. You got it. So immediate to register. We should probably also do immediate to memory. Then we need register. We do memory to register, register to register, register to memory. Immediate to register, register to register or memory, register or memory to register. Okay. Sir Aid, I think that wouldn't be useful as a bit mask. I'd rather just pass it like this. But you're correct, we could do that. So now, effectively what we'd like to do, instruction operands. So we would like one of these and say operands. Sure, why not? And then that's where it starts. Sir Aid. Oh my. You sound like me. That's normally how I sound. Sir Aid's going off in chat, back and forth, like, actually you could do this. Wait, actually no. Actually this. Wait, maybe this. So good. Okay. Effectively, we would like to have the left-hand side be treated differently based on the operands type. So let's see. We're basically going to have a source, right? This is also only for two operand things. So let's think about how this would work. We have this thing. And with this, we want to say if it's immediate to register, do this, if it's move, right? So we'd have a case move, and then we would have move immediate to register. So we'd have yet another switch on operands. And this would be, sure, why not? Let's see, instruction, what did I call them? Register to memory. So case blah. Three nested switch statements. Let's go. It's true. Well, we need it. There's not much we can do about that, needing it, you know? Okay. So now we move register to memory, register to register. So basically, ideally, we could kind of get all of our strings for all of our two operand things. For now, this is how it's going to go. I think this also goes to show how complicated the x86-64 architecture is. Exactly. It's not simple. So effectively, register name, source, register name, destination, and then int 64t memory offset. We'll think about how that works. So instructions x86-64 move. So when it's move, if it's a register to memory, we want the right-hand side to do this, the left-hand side to be normal, blah, blah, blah. In the case that it is register to register, we'd like to effectively just have two femit register name source. Oops. Register name destination. Okay, and then, so that's register to memory, register to register, and then we need case immediate to register. And it's going to be something like that. But yeah, this absolutely goes to show how complicated x86-64 is. What did I forget? How'd I miss a close statement somewhere? So switch on the instruction and get move. Why am I lagging? What is happening? Emacs, don't do this. No, it's probably ClangD freaking out because it's been, yeah, see it just exited with code 9. And now it's not laggy. Gotta love ClangD, breaking everything. We're basically just gonna say panic. Error. Unhandled, I don't know. Oh, it's doing it again. Jesus. Unhandled what? Unhandled instruction in x86-64 gas out code output. Wonderful. So if it's move, also let's see what we get to. What happens? It says move is undeclared because we've changed how things work now. And then this is going to be none. So we're going to have what could we have? What can we call this? No operand info. Like, I don't know what to call this. You know what I mean? What do I call nothing here? Because I want this to equal 0, but I don't know what to call it. We'll just call it OP none. You could put OP before all of these. We'll try it. Okay. This is basically going to be a panic. Build operand type in x86-64 gas code generation for move. Okay. Not bad, not bad. I've been streaming for so long today. I gotta do other things. Gotta get outside today. Okay, so we've done move. Still no good. Why is it mad? ClangD is still acting up. Did I not? Oh, I didn't. So we would like to move. I guess this could be, okay, here's what we'll do. This operands, this can be part of the variadic argument, right? I like it. Oh god, I suppose it could be, right? This is totally doable. So now we don't need a none. You ain't never need no none. Beautiful. So this is going to be op type. So immediate to register is going to be int64t immediate value into a register name. I think this is clear. Okay. So now move gets its operands, and then we from there get source dest offset type of thing. So now when we call femit, we can now pass, what is this? Immediate to register. VA start operands. Okay, that doesn't exist anymore. Fair. What's... Okay. More if zero. What's the issue? Expected blah before expression. Oh. There we go. And it's now back down to 12, I hope. Is it 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's probably 13. Already? We still get the bug. Oh god. What is this bug? Can you please tell us what it is? You're so mean. Dereferencing null pointer. Registers. Really wants us to check calc. I mean, we can. It doesn't matter. So let's just think about where we are here. All right. Mnemonic. Move. That's pretty good. Instruction. Move. That's pretty good. So let's try a little bit more complicated. Break it at the proper time. So why is all the white space screwed up? Like completely. Here we go. So if we start it, nothing happens, but let's try and get here. Never here. Okay, so we have, what do we have then? We have immediate to register, so we should be here. But we are not getting here? Oh, we're here now. Okay. What do we get? Args. That's nothing useful. Code. Okay, that's a file pointer. Context, yes. So there's no way to see what we got. Operands is immediate to register. Source is I'm not having fun. Offset is crazy. Just uninitialized memory. So we have the proper mnemonic and everything. Can we step over? Oh, Jesus. fprintf returned 26. That's a good sign, I guess. So if we go open code.s, see, there's nothing here because it hasn't flushed. But we're printing into code. You'd think we get somewhere. Okay. Well, stuff is happening, clearly. But we are not getting the right value. I'll tell you that much. Oh boy. What is going on there? Is that like 14 billion? Why? We're passing it args int64t. Immediate to register, followed by an int64t. Do I have to cast? I mean, it's a long. It should be the same thing. Maybe try putting braces around your cases. It's not going to help anything, but I can do it if you really care. There you go. Does that make you feel better? It still crashes, I promise. It's not the problem. We can put them around all the cases of all the levels. So we could go, where else is a case? There's a case here. Where does that go till? Probably this break, right? Sorade says, thanks, of course. So this is the switch itself. This is the switch itself. So we're going to start one here. It goes all the way up to the switch itself. So we do gas. Oh, I was probably in this switch statement. Okay. And then one more. Alrighty, now that is confusing. Still crashes. Can probably get rid of the if zero though. Okay. I'm not sure why we are having so much trouble. He just never got there. Yeah, that's what I was just thinking. Like, oh, I gotta put these inside their own thing. So char pointer destination register equals varg args char pointer. Oh my god, ClangD, stop. Please. It's making everything laggy. It's killing me. Might have to just restart Emacs. Okay, that worked. So don't call varg inside of fprintf is the answer there. Well, I know, we just planned to debug it like that, but now it works, so we're just gonna have that be a thing. That's weird. It for sure is weird. I don't mind. We're gonna look at the code. It's just all wrong. No, the code looks great. Code looks great. Okay. Well, so we're gonna have this. Oh my god. Okay, I'm gonna restart Emacs. This is getting to me. It's probably like the fact that Visual Studio is open or something. So I'm gonna close that as well. I'm gonna check my RAM, make sure I'm not going crazy on my usage so OBS doesn't crash. We're going okay. We're at 40%. Okay. Uncompiler, where were we? Source, CODEGEN. .c. That might be a compiler bug because I think var in a call should work. It'd be rare for a compiler bug to be both across MSVC and GCC. But it's possible MSVC isn't crashing, I guess. Return 0. Unreachable. I don't know -1 here. It's unreachable, so it doesn't matter. I'm just going to return 0. Okay, where were we? Jesus. femit. That's right. We're doing femit. And I was going to move this into move because I feel like this will help a lot. And this we will pass in our operands. What are they? So this is instruction operands. And then ... Okay. Okay. We know the mnemonic, but we'll get past it anyway. I know we don't need it. We could just use move, but it's fine. The file pointer code, mnemonic, operands, blah. I think that's pretty good. femit, x86, 64, move. Code, what else? Mnemonic. Operands. How do I pass the rest of the arguments? Oh no. Yeah, it has to accept a VA list. That's what I was just, figuring out. I was like, wait a second. So, it's kind of nice that we don't have to create another one anyway. Like that. That should work. Because now we can just pass in. Now we can just pass in our arguments. Why is mad? Because it's const. Whatever. That's why vfprintf, etc. is a thing. Yeah, like that. All right. If that is correct, everything should still work. Oh, good. I have to write my thing again. Build, and build func -v examples pointers. I'm in the wrong spot. Do you have to pass the mnemonic in this case? We just talked about that. No, but also yes. We know the instruction, but the instruction, we still get the mnemonic using that function, if you remember. So in different syntaxes, it may be different. Also, this just took forever. Unless FEMIT handles determining the correct mnemonic. I see. Yeah, it does. It just takes the instruction and converts it into a thing. Which we could just pass the instruction as well. Or just say, okay, it's move. We'll just use move. If you're okay with that. I really don't care. Right? This is fine with me. But I figured this would let us call this in a more variety of cases. We can try it. Let's call move. And what are the other cases? So we have immediate to register, immediate to memory. Can we move immediate to memory? Probably. So move this to the top. I mean, we can always add it back later. That's true. I like you, Saraid. I like you a lot. Memory. Destination. So we'll do register name destination. int64t memory offset. Right. So we're going to have to do the same thing where we move this number. Also, this needs a dollar inside of it because it's an immediate. We move this number. Also, this is technically FEMIT x8664 gas now. Why are you mad? Too many arguments to function call, expected 3. Oh, we got rid of it. That's right. So, technically this only handles the gas syntax. Because we're in the gas here. So we're going to just do move gas. x8664. We'll do gas move. Makes more sense to have x8664 gas kind of as one thing. Where was it? Jesus. Okay. This at least helps us stay a little organized. So we need all 5 of these. Immediate to register, immediate to memory, which means that this is going to be like this. Okay, so effectively, we're going to have the memory offset move into the register, the destination register. Oh boy. Star Aid says, I'm once again very sure that I very much prefer writing parsers over compiler backends, lol. Honestly, I like this a lot. This is one of my favorite things to do, is this kind of code. That's all squirrely and terrible, and like, how do we deal with this? That's my favorite, because those are the problems that are really hard. You know what I mean? So, immediate to memory, immediate to register. Register to memory, register to register. Register to memory, memory to register. Do we handle memory to register yet? Not yet. Whoops. Memory to register, right? So we're gonna have, I'm losing my voice. We're gonna have our little percentage prid with a percentage s inside of it. So we're gonna have memory to register. Oh god. So this is going to be memory offset register name, memory to register. So this is going to be register name of RIP or something. It also doesn't help that move is probably the single most complicated instruction there is. That's true, that's why we're handling it first. So register name of destination here, that's not right. Because this is our base. Source, right? So source is our memory address, is the confusing thing. Register name of memory address, right? And then we get, so we get our memory offset. Pretty sure we removed this from the end. We get our memory address register. Source? I don't know. Address? I don't even know what to call it. So we put in the offset first from this address, and it goes to destination. So offset address destination. So move blah 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 into blah. Does that make any sense? I don't know if that makes any sense. Okay. We're still, yeah, see, we're doing, there's double here. Lamau. So offset memory address destination. So we're going to call this immediate value memory address, memory offset address. We're just going to stay consistent in our naming with how things are used. Okay. Well, we're generating integers just fine. Move 42 into racks. Move 69 into racks. Does everything still work? gcc-o code.exe, code.s. Succeeds. Can we run it and get 69? We can run it and get 69. We didn't break everything, chat. How amazing is that? In doing so, I think this just means that, yeah, okay. This is going well. We've handled moves of all kinds. So everywhere there's a move after an fprintf, right? We should actually use femit x8664 like this. And then emit instructions. So what instruction is it? It's a move. Like that. Deabrieve is sweet. And what kind of move is it? It looks like a register to register. Right? So we're moving register to register, and we're going to move this little thing here into this little thing here. Moved into RCX. Look at us. Does that make any sense? So we emit a move from register to register from our result register into RCX. Hey, this is so much cleaner. Does that actually, I guess we don't do external calls, so these aren't gonna show. So where's an external call we can test? What is it? External function? Okay, let's do external function. So now you can see we move RCX into RCX. It's already in RCX. So now we only have to do this and say, okay, if iterator result register does not equal RCX, then emit the thing. Hey, look, it's gone. That optimization could be in the code that emits the move. Oh, you are a genius. Sir Aid, you are a genius. That's beautiful. Oh my god. So Sir Aid just recommended, we already have these two registers, right? We don't have them as descriptors, so we're just gonna have to string compare them. If these two strings are the same, we're just saying, nah, we ain't doing that. Is that what we'll have to do? And you could just pass a register descriptor instead of the name. It's a good point. We could try. And get the name in femit instead. Fuck it, we're changing things. Why not change them a lot? Right? See what you're saying? Go for it. Move iterator result into RCX. So this is more like ensure iterator result register is moved into RCX. Because it doesn't matter where you call register name. Exactly. So now up in femit, up in gas move, we're not going to have char pointers anymore. We're going to have register descriptors. And we're basically, can I do this? What do I call it? We don't have the context is the problem in gas move. What do we have? We have code operands, args. Yeah, we're just gonna have to pass the context. Or we'd have to like do everything in here, which I don't really want to do. So we're just gonna say code context. That's why the that's why the file should be in the context. You are correct. We would not have to deal with this. We would already have the context if the file was in there. We'll definitely make that change. Okay. It's going all over the place. Register descriptor. You have to compare the descriptors first, so you have to store them separately rather than just calling register name immediately. You right. Well, not in an immediate to register case, but you're correct. In register to register, we'll get there. Because an immediate value is never going to be the same, obviously. So we have register descriptor destination, memory address. Yeah, in that case, not, I suppose. But thank you for looking out. That is a good catch on that, a possible bug. So construct address, we don't have. We're doing immediate again. So here, it's no longer going to be register name, it's going to be descriptor. With memory address and destination. Uh-huh. So I guess I screwed up here. Yeah, we still have to do that, so this is fine. Register to memory. Register descriptor. Address. And memory offset. Okay. And this is going to be a register descriptor with register name. Const char. Pog. Surade. Let's hope VARG in a function call doesn't break again. That's a good point. I love the pog on the const char pointer. Hey, we can use them. And, yep. Okay. Oof. That was rough. A little bit of refactor on a refactor. And this is going to be source register. Context. Okay. That's pretty good. That's much better than what we had before. So now we basically just have to say optimization. I'm just going to clearly mark it. Optimization here. If source register equals destination register. Great. Could do something like this. Don't move register into itself. Pretty good. Oh, a little bit of an issue. What do we got? Passing argument 1 of register name makes pointer from integer without a cast. I didn't pass context. Why did it let me do that? Oh no. Yay, we're not gonna do that. We're gonna extract this. We're gonna say register descriptor address register. I don't trust VARG anymore at all, because it just let me call a function with 2 arguments with 1 argument, and that's not cool. So we're not trusting VARG at all. This is going to be destination. I can't believe that. Oh, Sir says, also on the subject of const correctness, that bug you had in register free wouldn't have happened if you had been using const, since free accepts a void pointer, not a const void pointer. Just saying. You're correct. Sir says, oh god, C, why? Yeah, so VARG is still messing with us in the function calls. So we're just gonna get them separately. I don't really mind at this point. Okay. I should put that in like contributions.md or contributions.org. Do not use varg inside of a function call. Let's just do it. Contributions.org. Do not use varg inside of a function call as an argument. Bad things occur. I think that's clear. Awesome. Contributions. First time chat from a new viewer, Pupil. Hey, any experience with MLIR yet or planning to look into it? What is MLIR? Is it like FLIR but with an M? Is it infrared imaging? What is it? What do you mean? Sir Aid says, time to write a linter that checks for that specifically, lol. Lamau. Just an entire program that greps, that like rip greps everything in the current directory and subdirectories, and it finds varg within parentheses, and it says, not allowed. Lamau. So we still call it here. So we're gonna have source. I can't believe it let me call a function with two parameters with one varg call. That's so scary to me. It's like they just ignore it. Error register name. Could not find register with the scripter of We did something wrong, folks. Lamau. Okay, so let's use all our vargs right at the beginning. Yeah, this is how we'll do it. Okay. Okay. So we're going to separate getting our arguments, using them, and then output. Sir Aid says the C type system really is more of a suggestion at times. I suggest that this is this type, but I have no clue. Alright, sorry I had to answer a text. Pupil says multi-level IR compiler framework from the LLVM org. I can't build LLVM on my machine, I have issues. Relatively new stuff to build compiler infrastructure, but not really that known yet. Multi-level IR compiler. Yeah, definitely not known, but it's not, I'm not averse to it. Make a pull request and use it, and we cool, baby. We get destination, address, memory offset, source, address, memory offset. We have source dest, don't move register into itself. See, this makes this kind of hard not to do. So we're gonna refactor this like that again. Because now we can say like if optimizing, right? And then we can just say, oh, if we're not optimizing, this will never happen. Okay, then we can get source and dest. Then we can print that. What was our issue? Register name. Why do we get could not find register? It's like we're passing a bad descriptor, but we weren't before, so What's going on? Source, address, offset. Source, address, offset. Sir Aid says, building linking against LLVM really is an experience. Oh god. Yeah, it is. It's not a good one either. So VR registers address, destination, offset first, offset, address, destination. I'm not sure what's going wrong here. I'm sure it's clear to you, but it is not quite clear to me. Because I don't feel like I changed anything. So, Do you want to see what I had to do to get a project to link against Clang's lib tooling? Oh god. I'm not sure if I'm ready. Immediate address offset. See, I'm still confused as to how this isn't working. Right? So it seems like, where do we call femit? What are we emitting for external calls? So we're a move immediate to register, register to register, and an add. That's it. That's it in the whole thing. So register to register we're doing. So we get source and destination. We never call VA end because we're meant to return and they're meant to call VA end. Make sure you're passing register descriptors and not char pointer. That could be it. Oh my. That's so terrible. Why, Clang? Why? Also, Brainsman, what's up? Joined during the stream. What a legend. Okay. Where are we at? So don't pass register name to fmit. Are we passing register name to fmit? I think we are. And then for add, I mean, we'll do the same thing. I think this makes sense. Hey, it worked. We did it. Okay, so external functions totally working. So I think femit is beginning to work how it's supposed to. Let's now move into RDX, iterator result register. And now emit into R8, iterator result register. Now move into R9, iterator result register. And then, yeah, we still have to do this. Emit x86-64 code context. And then what is it? The instruction. So this is instruction x86-64, and this will be call with this symbol. So let's handle call. Oh Christ. Do you need break in here? Do you not need break when there's braces? I honestly don't know. So with a call, we're going to say char pointer Okay. You do need break. Thank you, Saraid. Saraid says, well, there we go. The C-type system really is more of a suggestion at times, especially if you're using varargs, lol. Especially. That's good. You do need break, but the compiler should warn you if there's accidental fall through. It doesn't, but it should. No, you're right. So effectively, we just need to emit a call instruction. So we have to get the char pointer symbol, right? So this is going to be, we're going to have call and an external call. Call register, right? We're going to call register, and then we're going to have call symbol. Does this make sense? Maybe that could be an operand type. So this will be 2 operand instructions. Right? Instruction operands for, like, there's, this is so hard to describe. So this enum describes the operands of an instruction, right? That takes 2 operands. This enum describes operands. I think 1 enum is enough. So we'd basically have to say register as well. That's going to be harsh on the... Not all instructions with 2 args support all operand modes anyway. That's a good point. We'll have register, immediate, and memory here as well. Just by themselves. Okay. So if it's a call, we're going to get operands. And then we're going to say operand. And if an instruction only has 1 variant like idiv, we could omit the operand enum. Exactly. Yes, yes. If operand equals register, right? So I feel like we're going to need symbol here. You know what I mean? Maybe immediate is what we do, because we want a register but also a symbol. So we're going to say symbol. When this gets extracted to a separate file, all the names could probably be shorter since they're going to be local to that C file, or name. Absolutely. Or name. Yeah. You can go with name. I think that's okay. We'll see how it goes. Okay. Operand equals register. Right. We're going to have a register descriptor. And this is going to be, what is this? call address, sure. Okay, else we should like panic here, right? And say, femit x86 64 only accepts register or call or name operand type with call instruction. I don't know. I think that's fine. Okay. So I would like to print the mnemonic. I would like to print what? So we'd like to print the mnemonic, which is call. And if it's a register, we want to print the register name like this. I'm going to do register name. So we'll call this call register. We'll do this. We'll just say this is call address, which is the register name in the context of call register. We do our VARGs up top. We get our call address, which should move into here. And then next, I mean, that's it. We just want to call it. There is no next. Maybe can only call register or name. So basically, actually can only call, I don't know how to say that correctly. When you think about it, this is an awful lot of work for a program that takes text as input and produces more text as output. True. But it's going to be correct. And it's going to be a lot of fun along the way. So if we have symbol, then we just call symbol, right? I don't think it's that complicated. We get the name, we call it. Call put jar. Yep. Or not call put jar. So it's currently incorrect. For this call because we don't pass in name. Okay, so now code.s. Okay, we didn't do a new line here. Might be smart. Hey, we did it. Still working. Lamau. Okay, so call instruction, done. Emit. Code. Context. And we would like to emit a push instruction. And with the push instruction, we would just like to pass in this register. We don't really push anything other than registers, right? You can't push from the stack or from memory. That's at least not what we're doing right here. So for now, we're just going to keep push working on registers only. Push. Move. Call. Push. nothing. We're going to pass the mnemonic and then the register name of our register descriptor. And then we're going to say char pointer. We'll do like that. Char pointer value equals register name. Apparently you can push an immediate and memory as well, right? So basically, operand is equal to register do something like this. Else if operand equals memory, oh boy, fmit memory register register descriptor of value to push. Perfect. And here we're going to say offset, like base address and offset. So we're going to have register descriptor, which is address. And then we're going to have int64t, which is a what? Yeah, this will be a offset, memory offset. I think that's good. So we're gonna still have a register descriptor first, and then we're gonna have an int64t offset. Oops. Okay, then with these, we're gonna say what? Char pointer address equals register name on address register in the context. Print into code the mnemonic followed by what? So we would like to push something in memory with, okay, we're going to use prid 64. Okay. And effectively, we can then pass our offset and our address. Okay. Else if operand equals immediate, else panic. Error, fmit, x86-64. Basically only accepts register, memory, or immediate operand type. Push instruction. Sure. Okay, so now immediate. We're basically going to have what? We have immediate be followed by probably an immediate. So an int64t Immediate. That should be all we need, right? So we should just be able to do something like this. Uh-huh. And printf blah. Think like that. Oh, mnemonic. By the way, panic already adds a prefix, so this will print panic error. Okay, thank you. I appreciate. I never know. I just assumed since it's not, see, this is how you would write them normally, which is why I was writing them that way. So I figured it had no prefix. But if it has a prefix, I'll write them this way. Okay, so we now are outputting code again. So now this is all handled. My panic functions always have some sort of prefix and a new line at the end. Nice. That's good to know. It's very helpful. So boosh. I guess we could also just put a new line at the end here, but we'll do this for now. Okay, so theme it. Where were we? Does anybody remember? So fmit code context instruction call call. This is a register. And then what is this? Okay, function calls. Let's just do a little testaroonie. You can see call racks is working as expected. Failed with code 5 and no output. Well, that's not good. Honestly, that doesn't seem right. Failed with code 5. What's the greatest common denominator? Shouldn't be 8. Why do you break? Oh, look. It's probably this bush. Lamau. Bush. I see. I didn't add anything here. So effectively, we would like to say what? What do we get here? What are we pushing? Push arguments in stack in order. Pushing a register. Yes. The classic push random garbage. It's true. This needs to be a dollar. All right. Things are looking a little better now. So let's try. Hey, it worked. Now we fail with code 8, which is the greatest common denominator. Hooray. We would like to add an immediate to register. And the immediate would be count. And the register would be reg x8664 RSP. Does this make any sense? Unhandled instruction. So we don't have add yet. What am I looking for? Okay, so we need to add. Should also probably do popping, but that's going to be a lot. So case instruction add. So in the case of add, we're still going to need an operand. Operands, I guess. And then we're going to say switch on operands. Oh yeah. And what is this? Like register to immediate? Yeah, so we need to look at add. So we have immediate to register or memory. Immediate to register. And how this works is we're going to have code, which is going to be mnemonic, followed by what? A register. But first an immediate. We're going to have the prid thing. So we have an immediate number followed by a register name. Oh, I'm so sweaty. I feel like my keyboard is gonna like have a gallon of sweat in it at the end of this. Int64t. What is this? It's an immediate. Nope, args. I was like, what did I just do? So we're picturing f-init ... immediate to register int64t immediate and register descriptor destination. Okay, so now char pointer, whoops, const char pointer destination register. This is the register name, given its context, and the destination register. So now we can pass in our immediate as well as our destination. Whew. Okay. This is incredible. So with immediate to register, we also have immediate to memory. So let's do those. What just happened? Oh boy. Why are you mad? Duplicate case value. Oh, fair. Why are you mad about operands? Because things aren't handled in the switch. I default, and we're just going to panic and say, hey, this is a problem. We're basically going to say f-init x86-64. What did they look like? Only accepts. Only accepts immediate to register, immediate to memory, register to register, or register to memory. Horrible. I love it. Okay, so now immediate to memory we're going to have our memory address, an int 64T memory offset, right? And this is going to be an immediate into memory. So we still have our destination register, but that's going to be our address register. Oof. And effectively, we're going to write this immediate in a very similar way. So this is going to be prid64 for the offset. We could have a macro that does the var type thing automatically. I think that would be worth it. So if we created a macro that like did this part, this assignment, and all we had to feed it was these two things, that would be beautiful. I think that's doable. We'd also have to feed it args. So if we fed like get vararg, you know what I mean? We'll use like vararg and we'll say int64t immediate. Just like that. That would, I think, help us a lot. I'll add some macros to this, you'll see. Oh no. Oh no. Lamau. So immediate memory offset. Immediate memory offset. So then we get this immediate and move it into memory. Okay. And then register to register. Which is a heck of a lot simpler. So we add blah, 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 blah. So this is going to just be immediate to memory. Register to register. Which is just going to be source and destination. Whoops, whoops. What's happened? Okay. And then just move from source to destination, please. So add from source into dest. I think that makes sense. I mean, since it's always called args, I'd put that in the macro too, honestly. I think with var args that's okay, because you'll never be dealing with like multiple VA lists, and they're almost always called args, so just make a little comment about it in the macro that says, this requires a VA list called args, and then it'll be, I think, good enough, where we won't get confused in the future. There's one more, isn't there? I forgot what it was. Register to memory. int64t offset. Okay, so we have a source, an address, and an offset. Whoops. Oh yeah. Oh yeah. So now we add left-hand side of the right-hand side. So are these patterns the same? So we get immediate address offset, immediate address offset, and then get the register name of address and use PRID64 twice. See, I'm pretty sure these are the same thing. They're very similar, yeah. So how could I could have like femit x86 64 emid to mem. And what would it need? It would just need the VA list, right? It would need args. But I'm not sure about the details. I can definitely think of some ways of generalizing this, for sure. So if we omit an immediate to memory with a given mnemonic, right? So let's just think about what this is. VA list args, bar pointer, mnemonic. Right? I don't know if it's const or not. It should be. So we'll have a mnemonic. And then we're going to pass in, I mean, we already have this. So with the mnemonic, what else could we need? We need the mnemonic and then blip the rest here. Let's think about how that would work. 64. Then this is going to be immediate to memory. We're going to have a code file, which again is going to have to be part of the context eventually. We're going to need that mnemonic. We'll just make it const, why not? And what else do we need? So immediate to memory. So the idea is this mnemonic, the left-hand side is going to be an immediate. And then the right-hand side is a memory operand. So we're going to have, see, but all these are passed in args. And then we'll do this type of thing. All right. And then we can get this. Okay, so we're going to need context. Again, just another reason to put the file in the context. I know. We'll get there. Okay, so we're going to basically have code. Also, I named it capital C code. What is wrong with me? Code context. Mnemonic. Args. We're going to need mnemonic in here as well, I understand. But I think we can get rid of this. Because we're generalizing it, which is pretty pog, actually. So into code, write the mnemonic, followed by an immediate PRID64 into memory, which is another same number, offset by some register. Okay, so now mnemonic, immediate, offset, address. Oh boy. I think this will work. We still need mnemonic here. Okay. So instead of starting here, let's start somewhere else. So emit immediate to mem. What did we just have that made us think about this? Immediate to mem. Ethernet x86-64, immediate to mem. Okay, that definitely simplifies that up a little bit. Okay. Okay, well that's actually pretty pog. Okay. Just a bit maybe, yeah. Okay, so now in move, we're gonna have to do the same thing. So we're gonna move this back into move. Controversial, I know. Okay. Immediate to memory. x86-64, immediate to memory. Code, context, mnemonic. And ARDS. Hopefully this all works, by the way. Otherwise I'll have to undo it all. It seems to be moving. What did we change? Immediate to memory. Do we ever do that? No, we probably do immediate to register quite a bit, though. Immediate to register, which means that we'll just get a destination register. No offset. We can get our destination like this. Okay, show trailing white space. We can get rid of that horrid stuff. Okay. So now move this immediate into this destination register. Ooh. I feel like I should commit it and push it at some point. I feel like I've done way too much work without doing it. Code.s. So now moving an immediate, for example. Okay, an add. I noticed we did not put a new line. So let's just go fix that. The classic didn't put a new line. Okay. What did we get? Move register to register, immediate to register. Where do we have immediate to register? Here. And here. This seems to be going well. The add is going well. Okay. So let's continue this little change. So what did we just implement? Immediate to register. Immediate to memory, immediate to register. Okay. This could be a jump table for sure. With these as indices for each instruct. Oh, okay. We're gonna have an efficient code generator. This is gonna be cool. Immediate to reg, immediate to mem, memory to register. It's gonna copy you and figure out how this stuff works. Void fnit x86-64. What did I have? Memory to register. Mem to reg. Okay, so now we have our offset, our address register, and our destination in that order. And we would like to write the mnemonic, followed by the offset, the address register, and then into the destination, mem to reg. Gonna need that break, for sure. Okay, mem to reg. Well, this is pretty fucking dope. I'm just excited. This is cool. This is way simpler, and this is gonna be pretty cool. So now we're gonna have to have register to memory, I would presume. Yeah. So register to memory is pretty simple. Source register, address and offset. Do the thing. Okay, now register to register, the simplest one. Well, this is cool. So x86-64 kind of has like these meta shapes, is what I'm gonna call them, in the assembly and in the architecture. And we're basically taking one of those meta shapes and saying, hey, each of these meta shapes gets its own function. And anytime we need to make something, we can just use the meta shape of the particular operand. Obviously, these are all 2-operand, but this is pretty cool. I didn't think it would work like this, is how I'll say it. At least not this well. Reg to reg. I mean, still working. Very cool. Kind of worry that we're not freeing the allocated register, but it's fine. Okay. Yikes. So here's the thing. So they're all going to be a little bit different because of what they accept. So this immediate to register can now be x86-64 immediate to register. And immediate to memory, and register to register. And register to memory. I'm just picturing somebody looking at this code for the first time. It's gotta look horrifying. Like, all of these look exactly the same. And you're just calling different ones in a switch case. It's hilarious. So if it's add or move, see, the only thing we don't allow is memory to register. Add memory to register, right? Can confirm, it definitely looks interesting. So we can add memory to register. We can add register to register. We can add register to memory. So it does support all 5. It has immediates into register memory. It has register into register memory, and it has register memory into register. Eternal Wild Fox says, lol, back, I rested for a few hours. That's awesome, we have completely changed how CodeGen works. This much code duplication is really asking for a macro at this point. See, I think, Sir Aid, you go to macros too much and too fast. You don't need to go to macros for code duplications. There is other solutions, I promise. Sir Aid says, yes, I do. Well, you don't have to in my code base. Because look, all we have to do is this. Is that not true? Everything's handled now, right? Code duplication solved. You won't need to, but I want to. Sorry, it says, I mean, that also works, I suppose, but that's no fun. It's true, we won't spend hours and hours figuring out why our code duplication fix doesn't work, like with macros. It just works. It is no fun, though, you're correct. So we're gonna need to put these single into their own shape as well. Right? So we'll have like f emit x8664 reg, like register. I don't know. We'll start to see what the patterns come up as. So call, add and move have been handled, which is pretty dope. Let's figure out where we can call femit some more. Just keep making our way down, I guess, until we can't. That was funny. So we're doing a move, and it's a register to register, right? Okay, this is a little complicated. Hold on. So basically, we save racks. So we push racks no matter what. Let's just pop racks no matter what. I don't get that. I see, but if ours is in racks, I see what the issue is. We have to save racks. Eternal Wildfox says, normally you can define an install there with CMake if I'm not mistaken. Back to the CMake, lol. Yeah, you can do, most of the time people just create a target called install. So you do CMake -- build -t install, and it'll install it. But you can also use cpack. So we're just going to use femit without really figuring out how this whole thing could be better thought out. I just got rid of it because I was worried that the move instruction, maybe this is only supposed to happen if it's not, but I don't think that's important right now. So we can do what? Instruction, move, register to register, reg x8664 racks, and expression result register. We still need pop. At least move racks will get optimized away now, so true. True. I mean, it can't happen. That's what this actually checks for. But that CMake can download directly from GitHub is pretty okay. I would honestly probably never run your CMake script if it downloads things automatically, just in targets. I don't really like just random downloads happening without me knowing about it. Eternal Wildfox. Which is why people tend to not do that style. But it is useful. You're very correct. Oh Lord. Okay. Again, we're not trying to fix the overall code gen here. We're just trying to actually do it. So the immediate, here's the confusing thing, is 8. and it's RSP. So we need reg x86 RSP. Okay, we're making our way downtown. Oh boy. Lee. Anybody know how Lee works? But I like doing the GitHub submodule method better. Nice, I do as well. GitHub submodules are at least, I mean, they cause a lot of hair pull. They're very annoying sometimes, but I'd say they're better than like just downloading source and building it. Load effective address says memory to register only. Okay. So load effective address is basically going to have, it's going to go right next to move. And the idea would be that, what? Well, I guess the idea is that it's only ever a memory to register. So we expect memory to register implicitly, which would mean that we have an int64 memory offset, a register descriptor, memory address, and then our destination register. I think that's right. So we'll call fmit x8664 memory to register, mem to reg. Sir Aid says, I do, it works like this. Lamaui linked this page. It can have like 5 operands. Can it really? It looks like it can only have, just memory and 64 and a register, right? Memory to register only. Should be pretty good like that. Instruction count. Okay. Because we added Lee here. And we added Lee here. And now, also, when did we call Lee? So we never actually generated the fmit to it yet. Where are we at? I think this is where we were, because we have fmit up here. So this would be fmit x86-64 code context instruction Lee, and then this is going to be result, which is a string. Sir Aid says load effective address, displacement register, stride, offset register. You forgot one part. I'm just messing with you, but in all seriousness, you did forget one part. You forgot segment, buddy. Segment, displacement, register, stride, offset. Perfect. Yeah, we're never gonna, I don't think, use that. And if we are, it'll be a very specific use case. We'll figure it out, right? Screw segment registers, though. You right. You right. So the problem is, we have LEA, and we want to produce LEA result, and then register name. So memory to register, and effectively what we're going to do is say what? what memory? So what is result? Result is equal to a string that is either a label or what is this? Environment get by value functions. So we're getting the name of a function. So this is a name of a function, and this is a random label for a lambda. And we'd like to load the effective address of this offset by rip. So it's like we would need memory to address, but with a string. Okay, you know what? We're not dealing with lay right now. Lay is really difficult, right? So lay is just what I'm going to call it. The problem with it is that effectively this memory offset may not be an integer, but it may be a char pointer, right? So let's say memory label. Okay, so maybe another operand type is label. So memory label to register, along with memory to register. Could also just be name. What could be name, though? So name usually means that we're getting a string, the name of something, which is true. We're getting a thing, but the name has to be offset still. Name to register. Okay. I like it. I still kind of want to go label, like memory label, but I don't know. We'll go name because that's what we put up there. Why not? Okay. So with name to register or memory to register, so now Lee is not so simple. We need to get operands and switch. What is it? Lay only accepts? Only accepts name to register or name to register. So memory to register or name to register operand type with lay instruction. Okay. Case memory to register. And this is going to be name to register. See, if we did label, we could do LBL. Not that it matters, but then they'd all be the same length. Name to register. So we're going to have char pointer name, which is a memory label, memory address, and then destination. So we're going to go next to mem to reg. Name to reg. So effectively, we're going to get very similar things here, except that our offset is a char pointer. I think that makes sense. And with our char pointer, we're probably going to need both of these register names. And then, why is context mad at me? Oh, these don't have any types. I was like, oh, this makes sense now. Okay, so then we'd like to printf into code. What would we like to print? We'd like to print the mnemonic, and then the name, and then the register, and then the result. Mnemonic. It won't autocomplete. It's really annoying. Mnemonic. There we go. I was like, I'm not spelling it because I will spell it wrong. So with mnemonic, what do we got? What do we got? I've been streaming for like 5 hours. I haven't even told anyone. Go check out the Discord. We join and have fun. Brainsman did it earlier. He's a legend. But yeah, check it out. It's a ton of fun. I really recommend it. There's code review, there's announcements every time I go live, and just general discourse about programming. Along with that, check out the PayPal down below. I would greatly appreciate any and all donations that come in. If they have a message and are on stream, if they have a message that is appropriate for on stream, then I will read it. And if you leave your username, I'll attribute it to you. So be sure to smash that donate button. Even if it's just $1, it means a big difference because I don't have much, if any, source of income other than this. So thank you. With that being said, I just want to thank you for watching, and let's continue coding. So we do our mnemonic. This is going to be our name, by the way. So then we're going to have a name, and we're going to have our address register, then our destination. I think that's fine. So now memory to register, name to register. Those are both handled. Default panics. And we have an issue somewhere. A label can only be part of a statement. Okay, so we need to do this. Hey. 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 Okay, so we're still going well. Okay, somewhere around here. So symbol to address. This is definitely gas syntax only. It's okay. So cogenning a comparison. Ooh. So we could do XOR compare, and I think we'll leave set like how it is, and or we'll move. Yeah. I don't want to think about how comparisons would work. We're just going to move on from that. We have push racks. We should be able to do this. Cogen context. Instruction push register. Reg x8664 racks. Yeah. All those, all these, we need to pop still. So now I should be able to femit code, cogen context, instruction li with name to register, and this is going to be result. Reg x8664 rip for rip addressing. And then this is going to be our register name, which is just going to be our expression result register. So when is this? What is this for? Function. So we won't see it there. Okay, so for a function, Okay, we didn't do a new line. That's number one. That's pretty much the only problem. Based on what I saw. Hey, look, it's perfect. Failed with code 8 and no output. Perfect. By the way, what calling convention, if any, are you using for non-external functions? On the stack. Just everything goes on the stack. So we're eventually going to use the system's calling convention. That way we can have interoperability with C, where C can call our functions as well. But that means that we'll have to allow defining like publicly viewable functions in the object file. Does that make sense? Because currently how we generate functions is kind of difficult to map to the to C, because we don't actually have like a label that is the name. You know what I mean? We just have .l0. That's our function because it's a lambda. It's just a label. It doesn't matter. So this is our function label. And then we load the function label into a place in the executable, GCD Euclid, see? So then in GCD Euclid, when we write into there, somewhere here, you can see that we write the effective address of this label, but from C, for them to be able to generate a call to an external function, it means that the symbol will have to show up. So it would be called .l0 in C, which is not ideal, right? So we're going to have some way to define an external name that gets put in here as like, oh, this is a function, but it has an external name of my integer, and then that'll add. But for now, that's difficult. But for our own functions, we are just pushing all the values. So you see 88 gets pushed onto the stack, and then 32 gets pushed onto the stack. That's how that's working. Okay. We are slowly getting rid of all of these. It's pretty cool. So what does this do? See, this uses symbol to address. So we effectively just get... So symbol to address is basically RIP addressing global variables, or base pointer addressing. Okay, it's definitely doable with this new system. It's just not going to be super pretty. CODEGEN context. I mean, can't you just use the function name if there is one? Yeah, we don't have any like function name when we have a function. Though I suppose all functions are really lambdas, right? Yep, you're correct. So you're right that we are going to have like some specific way to add in a name in the assembly, which is pretty funny. In a lambda. So we're going to emit what instruction? An add. And it's going to be an immediate to a register. And it's going to be offset added to expression result register. So offset is our immediate, and then that's our thing. Should be all good to go. Still working. And that's in the index, so that would be arrays. We're not going to test that right now. We have test, which we should technically deal with. Right? And jump if not 0. Again, should deal with those. Test is going to be easy because it's just register to register. We got move. Instruction move. register to register. And then we have the last expression into the expression. And then jump. I love the semicolon, semicolon, hash, semicolon comments. Well, they're needed. Semicolon, semicolon means that it'll be indented the correct amount, and then the hash makes it actually a comment until the end of the line, and not an inline comment that will get pushed over to the side. Okay. If generate otherwise label. Femit x8664 code cogen context move register to register. This is the same thing as up there. Okay, Femit x8664 code cogen context instruction move immediate to register. And 64T 0 and expression result register. I am definitely gonna have to stop streaming soon. I'm very late today. I should really already have stopped, but I'm having so much fun. So how could I? We didn't do sub, and there's probably a lot to handle with sub. Seriously? Yeah, so we have immediate register, register to register memory, and then register. So that's all 5. 1, 2, 3, 4, 5. Sub is just add, but it's spelt sub, I think. Lamau. So let's just femit code, cogen context, instruction, sub. And then this is going to be register to register. And then this register to this register. Whoops. What just happened? I still don't know what happened. So we just add sub here. Should work. Okay. Pretty cool. IML might be a little complicated. Immediate to yeah. Oh boy. So basically we have register or memory into register. That's it. So IML is just register to register or memory to register. We're just supporting these. I know there are more. We don't need them right now. So let's go sub. So basically, in the case of IML, I also want this to be at the top. I don't know why, but I do want it to be at the top. So in the case of IML, what are we going to do? What is this? We need to switch on operands. Something like that. think that's good. And then we can say imul instruction, and we only accept register to register, R to R, or M to register. Okay. So now case memory to register. Emit x86-64, mem to reg, code context mnemonic args. And then, and in the case of register to register, generate that. So now imul, we support these, not those, these, where we can say memory multiplied by, yeah. So now imul, we're going to femit. Okay. Instruction imul, register to register, and then this register, oops, to this register. Okay. All in all, we're doing pretty good, I think. I know we don't have exact tests for everything, but the code is looking correct, which is a major sign that things are working. For divide, there's a lot we have to do here. So code, context, push. What are we pushing? Registers. And we're pushing register reg x86-64 racks. And our DX. So basically, we would like to say what? If right-hand side is in racks, we must save racks first. So if the left-hand side result register does not equal racks, move it into racks. So I think we can just do this. Cogen context. Instruction. This is going to be move. Register to register. And then this is what, two registers? So this is the, we're moving from result register. We're moving into racks. Okay. Do we ever use this again? Why do we have result register like this? It's literally only used here. Okay. Cool. This is something we'll have to support, but I'm fine with just printf right now. While idiv with right-hand side of division operator. Yeah, we're gonna have to support idiv specifically because idiv kind of has one register or memory operands. Is it worth it? Let's try. So idiv has memory or register. idiv plus kakato should probably be implemented together. Kakato. Yep, you're right. Because when we generate the idiv, right, I see what you're saying. And then this is going to be whatever this crazy shit is. So basically we're passing a register, and what we should do first is what? Assign and extend the value in racks. So we've already loaded the left-hand side into racks. So yeah, we'll just CODEGEN, because when are you ever going to use either without the other? Yeah, never. Pretty much never. Maybe sometime if we use... I mean, we're gonna have to do it quite often, aren't we? Because if we have a byte register, you know what I mean? If we're trying to assign extend a byte, then we're gonna need to use the CBTO or whatever it is, if I remember correctly. Or we're gonna have to do the succession of CBTD, CDTQ, and then CQTO. Or all the way up from byte to word, word to double word to quad word, and then quad word to octa word. Right? We're gonna have to like do a varying number of these based on where we are. I could be wrong. I could be wrong. In any case, let's just commit this. Code. Children context. IDiv. Perfect. Oh, why did I put it up here? Well, now. So for memory, we're gonna basically have to do what? We're gonna print into code the mnemonic, followed by a register name. So destination. And this is going to the register name. I guess that's for memory. I'm doing for register. So this is going to look like femit ... memory, and then int64t, memory offset, right? And then memory, a register descriptor for the memory address. CODEGEN and friends are only really used for division though, as far as I know. Yes, but we're gonna have to do it different amounts. So you can't, we'd have to pass all sorts of information to this function for that to work, I believe. And this is going to be register descriptor. And this is basically going to be what? Destination register. And then we use that. Okay. Whereas, what is this? We're gonna get the destination register. I guess this is the source, by the way, if I think about it correctly. Racks is the destination register, racks in RDX. So we're gonna have a memory offset. So Aid says, I see what you mean. Yeah, we're just not gonna have the type information available. So %s, IDiv, followed by number, followed by destination offset, memory offset. Okay. Not too bad. I don't think this is too bad at all. So we have a source register or not, and we have a memory offset and address or not. Ooh, something went wrong. Oh. This dumping. Yay. Alright. That's dope. We're doing pretty good. We're doing pretty good. So it looks like this is nearly identical. But you see the stars is different for the call, because it makes it an indirect call. So it seems like handling these singular ones case by case is the way to go. Oh Christ. Okay, so now we have idiv here. We do kokoto. This is kind of whack. It's a little better. We'll do that. So we'd like code. CODEGEN context. Move. Register. To. What is result register name? Why do we have that? I don't think we need to do that. So we can just say result register. Right? So result register is expression result register. And what I would like to do is move RDX into the result register, or move RAX into the result register. So I didn't type DX here. So we get a new register. We do a pop pop. Still not handled. What did we just do? idiv. There's no dividing in this whole thing. So we don't know if it's right. Let's just go add something then. Let's just do 16/4. FMN only accepts register or name with call instruction. Okay. What? Only accepts. I forgot what it said already. Register. Okay. So where do we call from? We have name here. We have register here. That's it. We have call, name, and register. And it says only accepts register name operand with call instruction. What? Are we falling through when we shouldn't be? Let's see. Did I forget a break somewhere? So li iml idiv. Looks like I did forget a break. My bad. So there's supposed to be one there too as well? There is. So that's for idiv. What about for iml? Iml we have break. That's better. So now we can see 4 is in RCX, 16 is in RAX. The answer moves to RDX. That's a bit of an issue. And that because then we pop into RDX, so then RDX won't be correct. Okay, so slight issues that we have to fix. So when we actually do idiv down here, what warnings are you using? I'm pretty sure -w wall with GCC. I don't know, honestly. I might have commented them out. None. There you go. All the warnings. An expansion of macro, pretty function. ISO-C does not support pretty function. No. So let's get rid of pedantic. You can see why I didn't have the warnings on. Zero length printf format. We could print a space here all the time. Sorry, it says, well, there you go. What do you mean, well, there you go? W extra enables W implicit fall through. This is so useless. Unused parameter format. Yeah, it's unused right now, asshole. What is last expression? Why are they mad about this? Set but not used. So in a function, it's saying last expression isn't used during type checking. Expression return type. Yeah, it's true. We don't use it. Get rid of it. Oh, Christ. Single lex operator. What is what? Oh, now you don't give them to me. See, this is why I hate errors. They show up 10 times in a row and then they go away for no reason. It's like, why do I have to clean first? Okay, what is this? Unused parameter format. It's gonna be unused parameter mnemonic in register to mem. Ooh, that's a big problem. Mnemonic. Mnemonic. Okay. What do we got? Parameter name. What are you mad about? Unused variable. I'm sure it was used at some point. Why don't we use it? I guess we just don't use the parameter name ever. We'll get there. Unused variable length. Yeah, is it known why we create a token or length here? Are those needed? Okay, we have your macro zero length printf. We have zero length printf. Initialization discards const qualifier. What do we got? Single lex operator. What are you mad about there? Unused variable. What? While state copy current head end is a white space is delimiter and is not an extend. This needed catch like blah blah made up of multiple. So we create a token and then never use it. Lamau. -w no format zero length. I'm fine with the format, with the warning. We'll just fix it eventually. Unused format, zero length. Comparison of integer of different signedness. Register descriptor. Sure. just asking for this, basically. The empty quote is absolutely necessary, lol. You don't get, it doesn't have to be an empty quote. Okay? Your mind works in mysterious ways, Sir Aid, I promise. You're a genius sometimes. But look, every time we use this empty quote, can't we just have a space here? Like, does that matter? Then it's not zero length? Could we have a bang here? Could we have a colon here and it formats it fine? Like, is it really an issue to have something there? I don't think so. You don't think so, right? You could even just have it be anything. Also, this is a weird way to test if a string is not empty. I just realized. That's a very odd way to test. Normally you'd use strlen or just check that pointer format does not equal /0. Right? You'll have to change the string compare and assert impl too. Exactly, that's what we just talked about. Yeah. So we could just do... Yeah, why not? Right? Does this make any sense? I think that makes sense. Hey, I did it. Look at me, I did it. Basically just, if it's the bang only, say don't do anything. But if it's the bang plus stuff, then just skip the bang. Skip. Flip. It's jank, but it works, I suppose. I mean, it's just as... I didn't change any code. It's not really jank at all. I see what you're saying, though. All we have to say is if skip placeholder for non-empty format string. Right? Looks pretty good. Looks pretty good. So now we just have 3 unused variables. That's our only warnings. Hooray! I'm sure there's some more pedantic warnings that really don't matter. Let's start some commit. All of this would be so much simpler if only we had VA opt. Lamau. Yeah. CodeGen changed just a bit. Oh boy. I don't even know how to describe all of this. So we're still in the middle of the refactor, but Suraid says, that's quite the commit. I know. It's like, well, this is gonna be everything all at once. Here, let's try this. Is that telling me there's no new line, or is it telling me there was no new line? There's definitely a new line here. So I think it's telling me there's now a new line at the end of the file. So let's do error C, error H, and say fix empty bug fix. Sure, why not? No longer cause empty printf string warning with assert. Good enough for me. Yeah, why not? Okay. Type checker. Parser. So this is just going to be removing unused variables. Bug fix. Remove unused variables. Some. Okay. A little better. Gnawing away. Gnawing away. Oh boy. Yeah, this is quite the commit. Basically just redo all of CodeGen is what I'm just going to call this CodeGen Overhaul. That's what's happening. We'll include that too, why not? I see commented out code. I did. Yeah, we don't need comments. We know it works. Gotta go stage that, you know? Okay. Oh, Christ. Looking pretty good. Uh-huh. Uh-huh. Hey, look. We can probably use this now, huh? Assert expression result register does not equal -1. Result register of expression not set, likely an internal error during CodeGen. Perfect. I like that. And the next commit will be CodeGen Overhaul Reloaded. That's right. It's going to turn into like Mission Impossible titles. Okay, what else do we have? Beautiful stuff. Okie doke. This is all going in one commit. Christ. CodeGen. Here, we'll do this. CodeGen Overhaul. Woohoo! So, instead of using fprintf everywhere, we have generalized some of the code generation into syntax agnostic functions. This will allow us to basically extend x86-64 backend with different assembly syntaxes much easier. Right? So instead of using printf everywhere, wish I could just keep this all as one. So instead of using printf everywhere, we have generalized some of the code generation into syntax agnostic functions. This will allow us to extend x86 with different assembly syntaxes much easier. Hopefully, we can get to the point where printf is only needed for comments, for verbose comments. I mean, that's kind of it. Hopefully it's only needed for verbose comments. And all actual code and instruct. I guess verbose comments, directives, etc. all actual code that is run, all actual code, instructions that will run in the final program would eventually be generated in this way. Speaking of refactoring, this reminds me, I recently came up with a somewhat cursed solution of distinguishing between less than and left angle bracket in my compiler. I'm curious, what is it? Because that's something we have a lot of interest in. Opens up our syntax quite a bit. Okay, there we go. We've pushed to main. Push, push. Done, done. How beautiful is that? We didn't even, like, do anything today. Also, we didn't fix dereference either. To do. This is still a really, really bad dereference. Fix me. Dereference should generate code to return the value pointed to. So dereference should generate code to return the value pointed to by its child pointer. Okay. Soraid says, I put it in code review. Let's check it out. So if followed by equals, then it is greater than or equals. If followed by right and equals, then it is, oh god, right equals, bit shift right and equals. And followed and preceded by white space, then it is right operator. Otherwise, it is an angle bracket. Oh Christ. If followed and preceded by white space, it is right. Otherwise, it is a right angle bracket. This is amazing. That's so messy. I love it. Case right. If next equals equal, next char. Else if next equals right, next char. Equal. Right assign. Greater equal. Shift right. Wrangle. I like wrangle. Right angle, left angle. That's funny. That's very awesome. Well, our code is now all committed. I've been streaming for 6 hours. So please give me money and give me a lot of it. No, I'm just kidding. But do check out the Discord. As you just saw, we do code review, we share things, we just have general discourse. There's announcements every single time I go live, so you'll never miss another live stream. Check out down below for the YouTube. I don't know if I honestly have that here, but let's see what I can do. Oh, I just switched you away, didn't I? Ooh, yeah, I can show you something. Guess what happened? We now have youtube.com/c/lenser. That's me. We have our custom link, baby. And yeah, you can see literally every bit of code that we have ever written for this compiler live and on stream in these VODs here on my YouTube. And everything else we ever do will be on my YouTube. Once we get to 500 subscribers, ooh, we got some shit happening. We're gonna unlock some things, some features. Ooh, we got comments. Oh, so cool. I gotta check on that. I gotta check on YouTube more often. But check out the YouTube down below. There's also the GitHub, which we can go to. You can see my compiler, my OS, my text editor, whatever you prefer. And yeah, all the changes we made today are already pushed, are live. So you can test this code out yourself, make pull requests like our lovely Arnau and Sir Aid have been doing. Shout out Sir Aid with the amazing amount of work in the compiler today, in the stream, being awesome, and just sharing his knowledge and being an all-around awesome dude. I very much appreciate it. But yeah, with that, that's in the GitHub. The Codeberg is very similar, and then there's the PayPal donate button. And I'm pretty sure you can figure out what that does, and I would greatly appreciate any and all donations that come in. I will read any message you leave on stream, and if you leave your name, I'll even attribute it to you, say how much you gave, etc. Shout out to RPWH or underscore RPWH. They were our last contributor. They are awesome in the Discord. They're always active. They're always a ton of fun and positive. So shout out RPWH, Rory, for being a supporter of the channel for a while now. Thank you, Rory. Even though he likes Rust. No, I'm just kidding. But yeah, thank you to everybody so much. It's been such a great time, and I can't wait to get out here, do this again, and fix up the rest of this code gen. Start having Lee be able to figure out how symbol to address can work, right? With our new emit. In any case, thank you so much. We have so much to do, and we'll get to it as soon as I can. Thank you for watching. Check out those links I just pointed you to. I'd greatly appreciate it. If you're on YouTube, check out the description. There's links down there to the Discord, to the PayPal donate, and to this source code. Thank you so much, and goodbye, everybody. I'll give you a little kiss right on the forehead. Are you ready? I'm coming in. I'm leaning in. I'm leaning in. Bye.